that will make the hugest difference on way that energy is going to flow. And if you make that slight mistake, it'll almost cancel your secondary out. So I don't know exactly how you got that done, but that looks beautiful. That's right off the top of my head. I'd say that would work to some degree.
Well, there it is. I had to write down all the numbers. I don't know.
Yeah.
Anyway, but so if I find that if I didn't have it written down, I got lost within the first few turns around. I thought, oh, where was I? Somebody said something, and then it's back to the start again. So
I'll
just having it written down like that.
For instance, I have part of a book that I'm making on exactly how to make these coils and the number sequencing as well. So I totally get where you're at. And you have to have it because you're in the middle of winding and you think you're on one number and not the other. You won't realize until you got 3 wraps around and you're like, oh, okay, that geometrical form is done. And you have to unwind it if you even can. And then start from that point. So, yeah.
Oh, yeah. No,
that's good.
It had to.
I applaud you. You're doing awesome. Without anybody's help at all? Did you have any instruction whatsoever? Did you just pick it up and go for it?
No. I listened to what Jeremiah said in terms of the principle behind it. And he basically described it fairly succinctly what it really was doing and how when I just 3D printed the initial kind of former for it with the posts, and then just thought, well, and it just became quite obvious that there was a way to do this to make it sequential, going around it and then changing the shape. And once you get to the natural finish of that one, you then start the next the next set of geometry. You get round to the starting point of that, having gone all the way around it. I mean, the triangles were the longest, and there was a relationship, obviously, between the amount of time you go around with the amount of connection points.
Depending on the form that you want, the coil you're looking for, and the field you're trying to form. Because every coil that you make will form a different shape of magnetic field, and it will increase or decrease your electrostatic field depending on the pinch of the coil, the form of the coil, how many layers you have. Is it like a set of stairs? Does it work like scales? There's a few things that are involved, but you're for just picking it up and listening. Hey man, hats off. That's good job.
Yeah, but I also saw that it has with ratios in it, because I mean all the geometries have different ratios to their inner angles as well, but also there's a rhythm in there as well. Which was interesting. That was noticeable when I was kind of doing it, and I've always wondered how to include rhythm in a coil, because it has a direction, and then all these different nodal points will strike different things at different times. Yeah, it's interesting. Yeah.
So when you're done winding your coil, use I would use plastic zap straps. That's what I use to solidify the coil, to get it to a point where I can put it in resin if that's the route you're going. And if you use the zap straps, it's like pinching the edges, and you can get rid of your posts, and then your coil becomes 3-dimensional. Like, it doesn't have to be nailed to a board, so to speak, right?
Yeah. No, I saw that from yours. You're using cable ties, right? Is that what you called?
Yep.
They're cable ties? Yeah.
Cable ties, zap straps. Kind of a different name for the same thing. Yeah.
There you go. Yeah. And then I've got that, so I can actually insert those around and then just wrap them and pull them tight to tighten up the outside edges of it. Yeah.
So now that you're building these coils and you get the fact that there's a rhythm, there's actually, like, I built about 175 different kinds, and the sequencing of where you put your triangles, your cubes, your hexagons, it matters in comparison to what you're trying to achieve. So if you're trying to achieve, say, a PEMF system for healing, I would put in certain, I don't want to say it just outright because we're going to show how to do this in detail, right? So it's like giving it away, but at the same time, I'm not charging for it. I'm still giving it away. But we talked about doing a structured class on teaching this. But there is a sequence that can give you, I wouldn't say free energy or over unity. I'll say real efficient system. Okay.
Right.
And then there's another sequence that would help you get lift. And then the same form, but a less windings on certain wraps will give you a really good PEMF system for pulse electromagnetic frequency healing. So when you start building different coils and testing them, you're going to see how they kind of come together. But a word of warning, until you get to the level where you've done a bunch of testing on smaller coils, I personally wouldn't go over 18 inches. Just until you get to the level where you understand how the fields are going to be pushed out, how they're compressed, how they're pinched. Because if you go a little further than that, your outcomes are different. Because you can scale this up, right? But your anomalies get a little bit more intense as the coils get larger, and then your efficiency for putting out energy is a little different. It works differently. It's hard to explain without giving away the golden goose, right? But I mean, we're going to give it away in a very near future video series. I'm actually going to do my presentation on Old Man Builds and Bernie's Friday night free energy. I'm not waiting for APEC anymore. So
okay. Oh, yeah. Cool. Excellent. Oh, that's good
so
to hear.
It's coming, and it's very, very, very shortly. Maybe this Friday. Depends. I got a couple contracts I have to complete this week. We'll see how much time I have, but hopefully this Friday, maybe next Friday at the latest. So that's where I'm at with that. Anyway.
Nice. No, I look forward to it.
Sure. I appreciate you doing this work. That's anyone and everyone that can get into this, who can pick it up like you, they should. Like Nathan, on top of his game. Ben, he's doing the same thing, just slightly different. We're all working on the same principle, and I think everybody and anyone who can or even has the desire to do this should. So, good job, man. That's awesome. It's awesome.
Yeah.
Well, I'm sorry. Go ahead.
Yeah, no, it's okay. I was just going to say, I've ordered more wire.
So, can you guys explain
a lot more wire?
I hear that. I have spools. Go ahead, Nathan.
Can you guys explain wire gauge, and then also, Ian, if you don't mind, can you explain the tones versus the coil? And I'll put the coil back up. You guys hear me?
Are you talking? You mean the ratios of the
what's
angles?
The wire gauge you guys are using to wind your coils?
The wire.
Did you want to go ahead first, or do you want me to? Go ahead.
You go ahead.
You want me to go ahead?
You're doing it right.
Okay. So the coil that you see that's 12 inches with the pickup coils around it, that's 22 gauge. Both the primary and the secondary are 22 gauge. On one of the previous lives, I had said they were two different gauges, but I had looked into my notes and I was wrong. I apologize. Don't hang me for it. But they're both the same gauge on the primary and the secondary. And I don't know. I've worked with quite a few different gauges from 32 all the way to 16, and your power ratios change. Again, it comes down to what you're trying to do with what coil you're building. So for me, between 20 and I don't know. I like to use between 20 and 26 gauge, give or take. I don't know what you're using for your coil though.
I had some 28 gauge,
Yeah.
and so I was using the 28 gauge just to start with, but I've got a couple of big spools of 22, so that's good to know as well. But I was doing it on a, I was having trouble getting the posts. Some of them kept breaking off and things like that. So eventually, I just kind of thought, well, I'll use a thinner gauge wire, and then it should be able to hold and not put as much pressure on the posts as it gets higher. So yeah. And again, I wasn't even sure because I didn't want to damage the wire by making the posts V shaped. So because I wanted to make sure that the angle was maximized for what it was supposed to be, rather than it rounding off too much as well. So I wasn't so sure about whether that was right or not either. But I just thought if maybe just working on the principles that I was and just rotating it around using the different geometric forms, I thought that if there's something odd, if I might find something different. Who knows?
I think you have. I'll give you a bit of a tip. When I first started this, what I used was a piece of wood, and I used carpenter nails, the big, long 3-inch ones.
Mm-hmm.
But I put a plastic straw over each nail as I nailed it into the 24 points, so that when I wrap the coil, I can put as much pressure on the posts as I want. And then when I was done with it, as I put the zip tie through it, I can literally pull the straw, pull the zip tie, done, and pull the nail out. It was no issue whatsoever. So I don't know if you want to go that route, but it's just it's what I did when I began.
Right. No, that makes sense.
Yeah.
I had the 3D printer, and I thought, I'll just print out a former and see what it goes like. So yeah.
If I had a 3D printer, I would have done the same. So yeah, I understand. Yeah. When it comes to the gauge of wire, I don't think it matters so much as your gauge after. Oh, I you know what? Between 32 and 20 really doesn't make a difference. It doesn't matter if you're running high voltage or high current, because of the way that the geometrical forms allow the energy to flow in the system. It's almost like once it's flowing, the toroid shape of the coil itself acts as the full current where the current's running. I'm not sure if I'm explaining that properly. As that energy is flowing geometrically, the toroid itself becomes one. So it's like, instead of having all these individual wires and layers, they all become one magnetic tube. And at different frequencies, it does different things. So,
and you have the differential pressure from across from the top to the bottom, and that gives you your polarity, and you've got your equatorial plane is right through the center, I presume, horizontally.
Absolutely. And different forms and different sequences will push that field out further from your sides, or cancel it out altogether and focus it strictly in the center, depending on what you're trying to do. These geometrical coils, they're the key to a lot of different tech.
Sure.
Have you started pulsing it yet, or are you in the process of still winding?
No, it's still winding. I've done half of it in terms of what I wanted to do, and now I've got to go 180 degrees and then start from the other direction. I'm assuming that's the horseshoe point of whereas one coil is overlaid on top of the other. So I've got the first. I think what I've done is built what I thought was the first coil, going through, going out, and then back in again, and then I was going to reverse, just basically turn it 180 degrees. So I'm starting on 12 instead of 24, and then I'm going in the opposite direction to be the same as the horseshoe thing. So you've got an open system in the center, but then one coil, and you still have the ability to join one coil to the other externally if you wanted to, because the wires are all there. So I wasn't sure exactly.
No, you did good. How do I put this? This is a little piece of constructive criticism. Please don't take offense. For what you've done is amazing. And this is why I think when me and Nathan were discussing about teaching a class on this, I kind of have to teach certain points specifically. And what you did for the 180, I get it. That's what most people actually do, but that's not how I base. There's a very specific principle that I kind of kept close to my chest on this one, but it's the way that you wind the coil. When you wind, say, one form, let's say a triangle, and you're winding it clockwise. So you get your form done, then you wind 180 degrees out of phase counterclockwise, that same form. Then you switch your next layer.
Oh, okay. Okay.
So that gives you the ability to layer and capture the skin effect in between each layer as they're crossing.
Gotcha. Oh, okay. Interesting. Yeah.
Yeah.
That makes sense.
It, like I said, it's
Nice.
something I've kind of kept close to chest and not told too many people about, because there's people out there that are trying to, let's just say, obtain this nefariously. Just trying to be
Ever since I got into any of this, that word nefarious is pretty common.
yeah, you understand.
Yeah. Oh yeah. Totally. Yeah. Yeah.
Well, it
No,
goes against regular
I think
physics in a sense. So academia doesn't like that. Sorry?
What you're doing is fantastic, I think. So it's just great. And it's great that you're sharing it as well, for so many people to keep it close to them and die with it usually. But
It was given freely to me, so I want to give it freely to everybody else. But at the same time, I've protected myself. When I first started this journey, I was trying to get it open source really quick and give it to everyone, right? And I still want to do that, but there's a certain way of doing it so that, like you said, there's nefarious people in the background. So, you got to have safeties in play once you start to see certain anomalies with these coils. I have 3 dead man switches, and they're set up in 3 different medias, 3 different forms. So if anything stupid happens to me, I'd never commit suicide in a million years. My beliefs wouldn't, I couldn't do it, right? So that being said, you still have to protect yourself in a sense, because we're dealing with technologies that have been found before. This isn't like there's nothing new under the sun, but it's new to this generation and new to the people that haven't played with it, which is, me and others. And so as long as I think everybody's open and shares their information, then this tech will get out to we may not see it in the market in our time, but our children might. And that's kind of my goal, is to kind of get the info out, get people working on it. Just like John Bedini used to say, let's have the people decide. Let's put it out there. If they want to work on it, if they want this type of tech, great. If they don't, that's okay too. Some people don't have time to put systems like this in their house or tinker around and find how these systems work. Some people would rather just pay a bill. That's okay too.
Mhm.
You know what I mean?
Oh, for sure. On a practical note, though, if you, I was looking into. I know you're not keen on Malcolm Bendel, but I took a look around down that rabbit hole, and
So did
what
I.
I did was he actually he put in patent applications to protect his ideas, not so that people could not then just take it and produce a patent and then just bury it. Right.
Oh, I get
Because
that.
then he wouldn't legally have any rights to it anymore. So that's also a consideration as well, right?
I thought about that, but that's why I keep certain points to myself that'll only be taught in private. And if somebody was to choose to do that, with all due respect to the law, I don't care. I created a lot of the things that came to bring this tech together. It's not my tech, but at the same time, I did 15 years of work on it, and I don't care what law says what. You're not going to stop me from sharing this information. You could take me to court. I don't own anything. So what are you going to take from? Blood from a stone? Good luck. I know it's kind of a bad attitude, and I apologize to everybody out there listening, but I'm not in it to win it. I'm not in it for the money. I'm in it to just share the truth that I know, and you can take it for what it is, right? And when it comes to patents, I kind of view the patent office as legal thievery, right? Because if I put my system into the patent office and they decide, oh, well, this is a really good system and I want it, they're just going to take it and shelve it, and then nobody sees it. For others, I understand, go that route. If you have the money to fight big corporations and 20 lawyers at a time, then go for it. I personally don't want the battle. I'm just going to share the information as knowledge, and I hope that if it turns into something for everybody, that they... For me, I like it like this. If I was to teach one person, under the obligation, I would only teach that person if they taught two people. And the two people that they taught have to each teach two people, and so on and so on and so on. And that's how I kind of think that we should be getting this tech out. I agree with, in a sense, the way that Malcolm Bendall is expressing it, because he patented it to protect it. But I did a deep study into Malcolm Bendall as well. Awesome tech. Unfortunately, it was created 40 years prior by a man by the name of Paul Pantone. And he didn't share his tech. He tried to get it patented, and he tried to go the route of education through universities, and they locked him up for it, tried to commit him to an insane asylum. And then what they did is they let him out when he was, I think it was years later. And then he went to another country and created universities teaching people how to make the Gault motor. And Malcolm Bendall's system is essentially the Gault motor with an external reactor, whereas Paul Pantone's system has an internal reactor. They're the same system. So, I mean, I applaud Malcolm Bendall for doing the work that he did. And the fact that he's put it into ships and cars and trucks, hey, man, hats off to the guy. But I think it was somebody else's tech that got embellished on. That's my opinion. Yeah. If I'm wrong, hey, prove me wrong. I'll admit that I'm wrong, and I'll apologize. I have no problem being wrong. But
no, but from what I've heard of him speaking about it, he hasn't really said that he said that these are the ideas of other people that he's just pulled together, and but basically he's got his model there. So it seems, I mean, anyway, but I mean, it's interesting. I just brought it up because of the whole protection. The information, totally. Just to prevent other people from actually seeing what you're doing. And then, I mean, this has no moving parts, huh? I mean, it's perfect. It's like a solid state energy machine, right? Solid state.
Remember,
that's going for gold.
There's no moving parts, as in say moving magnets or a spinning wheel, but there are moving forces. And you have to take that into account when you're building these systems. So, but absolutely, this is the goal, right? To literally put it in your house, put in a ground wire, put in an antenna, hook it up to the system, turn it on. That's it. That's the goal.
Yeah.
And if you want to pay for your hydro bill, by all means. If you want to build something like this, even better. That's the way I see it. Yeah.
Cool. Nice. So I look forward to your presentation on it. It'll be great.
I appreciate that. I'll do the best that I can for everybody that's out there. I'm going to kind of do it in two ways. I'm going to give a scientific explanation and presentation, and I'm also at the same time going to lay out the layman's terms, like when I'm talking about, say, the Miller effect or the skin effect, and then I'm going to explain what that is. And I'm going to do it in backyard lingo so that everybody gets it. You know what I mean? Why keep it hidden? Yeah.
Totally, yeah.
So I appreciate that.
No, I look forward to it.
Did that answer your question, Nathan?
Yes, you guys did. You guys are doing awesome. If you don't mind, I'm going to show your coil real quick, Gerald. And I want to show what you put up the last one that you did. So,
was that the question on the Oh, that one. Yeah. Is that the 300 volt one, or is
no,
that?
it's not. You never posted it.
Oh, right. Yeah. Okay. I apologize to everybody out there. I remember why I didn't post it, because I didn't have time to do the editing.
121.
I did get that editing program from you there, Nathan. I appreciate that.
All on the interior.
Sorry, let me rewind it.
Okay, I'll shut up.
3 coils, 3 meters. Check it out. 3, 2, 1. 121, 175, 97. 3 phase. All on the interior. Have a great day.
All right, Gerald, you want to explain what's going on here?
No, I'm just kidding. I'm kidding. I'm kidding. I'm kidding.
That's not right.
You gotta have fun. Life's short, right? Okay, so you want me to start from the beginning as to what I'm doing here with the circuit and how this is working, or just okay? So
yeah, go ahead. Whatever you're doing, the setup of it, and then into how you got the numbers.
okay, so normally these coils that are sitting on the, like these pickup coils that are sitting on the inside core of the vortex coil, they're wrapped to the 120 winds. They're ferrite cores. Usually they're perfectly 120 degrees apart from each other, but one of them fell and I just quickly pushed it into the camera's view. So that's why you see how it's off. But when they're 120 degrees apart, the voltages balance a little better. So they're not so different. That being said, the circuit that I'm running this on is a horizontal deflection transistor out of a 28-inch tube TV. I believe it's a C20, it's a C2558, I believe. And it has a 12-volt battery for a power supply. I'm pulsing it with a function generator on the primary only. And so once it, so once I pulse it on the primary, the secondary, the 2 wires that come off there are just going to a hairpin circuit without a load. So it's basically like a spark gap, and then it's got 2 capacitors, but I didn't complete the circuit. I just left it as it was. So then using the horizontal deflection transistor, because it has such a very fast rise time and a very fast fall time, I'm able to get these voltages. And the faster I can pulse the system, the higher the voltages go. So that's how that particularly works there. What you're seeing is me pulsing the primary, and the secondary, the field builds up in it, and when it collapses, creates a spark, shoots back in, pushes into the primary, creating a current, kind of like a wave, right? And that's how you're seeing those voltages. And there's a different voltage set that you can get on the outside of the coil. So as those 3 pickup coils are in the inner core, let's say the 175 volt one in the middle meter, and you can put another one right opposite to that, I should pick up somewhere around 50 to 60 volts just on the outside, right across from that one coil, because it matters. They link, but they link by inductiveness over top and underneath the coil. So it's kind of unique how it creates a vortex. And then ferrite picks it up so easily. So that's what's going on. Did that answer the question?
Absolutely. How about you, Ian? Your mic on? I see you talking.
It might be muted.
I was muted, yeah. Sorry. The pickup coils between the inside and the outside, though you've got that differential of voltage between the two. So
Yeah.
does it actually create a current through the wire coming from the inside coils pickups
Yes, it does.
towards where they're going?
Yeah, and
So
if I take the two pickup coils, say one on the inner core and one on the outer core, and I'm to cross each line, so the output of one of the pickup coils on the inner core and the outer core's input mixed together, so it acts like almost like a PMH winding. I get even more out, and I get more current out, but a little less voltage, right? Because it's cross fielding at the same time as picking up that vortex. So, yeah.
Right.
Does that answer your question?
Yeah.
Perfect.
So, and is it cold? Is the temperature is different in the center to the outside?
Yes, it is actually. It depends on what I'm doing. I can make just the center hot and the outside a cooler temperature, or I can reverse that and make the inside cooler and the outside hot. I wouldn't say complete control, but I have a lot of control when it comes to that. And that has to do with the pitching of that magnetic field and controlling it. Yeah. Any other questions on this one?
You know what? Just if you don't mind, if it's possible, how many layers do you have in your coil?
Oh, you know what? I didn't count it by layers because this one.
I meant like in like each coil as one layer. So is there 3 different coils in there, or is it 2, or is it just one round coil?
It's how do I explain this? Let me just think about this for a second. How to explain this so it's understandable. It's 2 coils, but it's not 2 coils until you wrap the whole thing, because it's wrapped on one wire. And then it's cut in a specific part, making it 2 coils. Does that make sense? That's why I kind of have to teach how it works, right? Like, because it's not an easy answer. It's because of the way that I wound it, right? Let's just say I was inspired to wind it this way. It's all one wire, but it's cut in the middle in a certain way where it makes 2 coils.
Gotcha.
Oh, wow.
You could
what was your inspiration for doing this in the first place? What brought you to this kind of design?
Honestly, it started with the Jewel Thief, John Bedini's schoolgirl circuit. I thought it was just amazing, right? You're lighting a little 110 volt twisty bulb with like a little AA battery. But then after working with that and some time, I had a very amazing dream, and it inspired me. And it gave me the very specific numbers for the coil that you see me experimenting on. And once I built it and started experimenting with it, my mind was blown. And ever since then, it's just been after another one, after another, after another. So I started winding them, and like I said, now I'm actually not at 175. I'm at 178 because I just built 3 new coils that haven't been seen before. And I'm going to display them shortly, probably on the presentation. But anyone could build them. Once, like you've seen, once you have that principle down, it's just like flowing, right?
Right.
Yeah.
Very cool. Nice. Yeah.
This is actually kind of something you could look at if you were about to start winding coils. Dream catchers have a very unique way of winding. I wanted to mention to you, though, If you wanted to wind like a basket winding weave or something called a starship coil, there's a gentleman on YouTube called Mike Powers, and I built his coil. He was the one guy built after Rodin, and his coil, he gives you the numbers on his channel, but he says you can't use his coil for military purposes or any other purpose because he found that it does unique things. But my system is a little different than his, which thankfully they won't coincide in that way. But if you wanted to maybe get an idea of how I do the inner layers, he's a good gentleman to start with. Mike Powers. Just as it sounds, it's spelled.
Yeah.
I don't know if that helps you at all.
There's oh yeah. I mean, I have a myriad of questions, but I'll just wait for the presentation because it'll all come out then. But there was a presentation this girl Sheila did on the Cosmic Summit, and she was actually showing, she was using a Rodin coil, and she was feeding frequencies into it. So she was heterodyning of frequencies, right? Yeah, there she is. This is amazing. So you see the coil she has on the table, and then she's actually picking up. She's got a handheld coil pickup, and then that goes back into the software, the scope software on the in the computer. And I mean, all the numbers that she chose were all mod 9, so they have that inherent stability in them. But she's now showing a representation of what the geometric form in 3 dimensions looks like around the coil. And I was thinking, like, would that be incredible to see for your coil, for visualizing the electromagnetic fields and how they're all interacting at the same time?
I would love to see that myself. Nathan was saying that there's a program out there that does that, and if I can get my hands on it, I'd love to try it just to see, because there's I believe it's very intense.
Well, you remember, I mean, it's another vehicle as well, is that the circuit that you were using, your signal generator to play tones through the coil.
Yeah.
Right. So if what I found was some other testing that I've done, I was looking at the acoustic resonance, physical acoustic resonance of coils, and I was surprised. I mean, I was using quite a thick, I was using a rigid coil because I was vibrating it with a resonance speaker at one end and getting the vibration to go through the coil and using microphones just to pick up when it was resonating. And it was unfortunately, it was about 7 kilohertz, was possibly the most annoying frequency you could actually have to listen to. But certainly the complaints from the house were coming to, I just had to stop. But the acoustic resonance is much lower than its electromagnetic version, the counterpoint, obviously, right? But so it's really down there in that audible range, and that took me by surprise. But if you're then able to electromagnetically place those tones into the coil, and you find where the coil's natural resonant point is within the acoustic range, that it's another area that I think is probably, I mean, I think that we should be able to use acoustics for everything, I think.
Well, it's funny you bring that up, because if you were to take what's it called? It's a digital tuner for acoustic guitars, and I've taken a mic and I plug that into my little tuner, and I run it over the coil while it's running, and I get every note that you could possibly imagine. And if I turn it up on a certain frequency, it just rings C. So the acoustics in a very tightly wound basket winding coil, they vibrate at such a rate that your ear can pick up on that very tone. I can play a sound. I could play a song on my coil just from those tones by playing with my function generator. Nothing else around. There's no cone, no nothing. Just the very vibration of those wires creates those tones in the air around you. Maybe they're vibrating the air molecules. Maybe they're vibrating nitrogen or the oxygen. I'm not really sure, but you can, like you said, definitely hear it. And if you have too much amplitude in there, the house doesn't like you. My cats, they don't come around me when I'm experimenting. It's kind of funny, but yeah. So I understand when it comes to acoustics for sure.
Huh. Interesting.
Yeah.
Yeah. No, I'd love to see that.
Yeah,
But being able to see the visual representation, like on a 3D representation of what's going on, is it's just another area of fascination. Be great.
absolutely. I'd love to be able to
Yeah.
see it. I put iron filings on the top of my coil, and it would just show me. It would almost act like a single line. And I was bringing that up to Nathan, and he suggested that the magnetic field might show up on the outside, on the sides of the coils, rather than on the top, because of the way that the system works and it polarizes the fields around it. So, depending on the way that you built your coil, you may not see any iron filing visualizations either, and you might actually need to do a three-dimensional program like what we're discussing. So something to keep in mind, right? I think that scalar or ether or the quantum vacuum, call it what you will, I don't think it shows up on iron filing systems, but I think that the magnetic field that's created in order to pull that in shows up on the iron filings. It's just a matter of finding it.
Yeah, for sure. So I think what the system that Sheila was using was actually it was and somehow she was taking it up in octaves into the electromagnetic spectrum within the coil, and then the pickup she was using was actually bringing it back down into the audio range, but in a visualizations way. And then the software that she had in the computer was able to actually relate that back, having gone through the electromagnetic system and then coming back in and showing it that way. So I'm not exactly sure how she did it, but I did email her and she replied eventually and said about some of the gear she was using, but not all of it. So, but it's interesting. For sure.
That is very interesting.
Yeah. Okay, so we got a question. Wonder if the air density changes the effect.
No, but you can change the effect of the air density. Does that make sense?
Yes, it does.
Yeah, you can actually condition a room, and I've done this in my garage compared to my house. I was doing experiments getting 100 volts out of each coil and pickup coil, and then I moved it out to the garage, and I was getting like 27 or 30 or something. I was like, what's going on? And then after a couple days of experimentation, right back up. And I couldn't understand it. And I think it has a lot to do with charge compression and charge density within that room that you create after experimenting. It's just a thought, a theory, not sure on it yet. But yeah, I think you can change the air.
So are you saying that the charge doesn't dissipate in there, in the walls, or just in the air?
I don't know about in the walls, but I would say in the air. Like when you're creating an electrostatic field such as this with a magnetic component in it, in order for... Okay, I'll give you an example. I was doing a test. I had the room sealed. There was multiple windows in this room, and the door was closed, and I had run it for about an hour, hour and a half, and I had to like blow my nose or plug my nose and blow out my ears because it felt like I was walking up a mountain and the pressure was changing in the room. So I shut the coil off, but the pressure was still there until I blew off a capacitor that was linked in the system. Because that implosion quick snap went off, it was like the bubble burst and the air pressure was normal after that. So I don't know if that helps you at all, but when it comes to charge, I believe that an implosive effect, like the blowing off of a capacitor, like shorting it out, it pulls all the energy in, and I don't know where it goes. It dissipates it. Maybe the sound dissipates the energy that gets pulled in from the implosive effect. I'm not sure, but in my experience, that's what needs to be done when you change the pressure in the room.
So you actually created like a field bubble in there that contained what you were doing until you let the energy spark, and then boom, the bubble was gone.
Yeah, and I have witnesses to that who will testify in a court of law any day of the week for it. So yeah, it was crazy.
Amazing.
I had no idea that was going to occur. Otherwise, I would have kept the window open. But it was a good thing I didn't, because then it showed me that, you know, these systems aren't, they're not closed systems in the sense that we would think what a normal transformer is, right? There's lots of anomalies that surround these vortex systems, especially ones that are vortex in 180 degrees out of phase and still working. There's a lot to map out on them. I've been working on them for about 15 years, and I'm barely scratching the surface, right? There could be 1,000 of us working on this, and I don't think we'd complete the work. That's how intense it is. So
we have a question from the chat real quick. What is the max or minimum of the device?
I'll be honest, I don't know that yet. The last large test that I did, I used, one sec, I'll show you what I used.
I think what you were describing before is you said it's kind of based on the load as well.
That was my load. Okay. Just a 900 watt electric element. And
it's a heating plate?
Yep, it's a heating plate. So I used that as my load, and the coil got really cold. And I have a, where is it? Big neodymium magnet. I don't know if you could see that. It's 2 inches in diameter. There's two.
That's a big sucker.
Yeah, there's 2 of them locked together. So that big coil that you see, I had turned the 900 watt element on, and I had put the magnet in the center of the open core, and it sucked it up, held it, like levitated it, and then I could tap it with my finger, and it would roll around the inside. I did a video on it, and I called it levitation, magnetic levitation, and it spun, right? And that was from the load that I was using, and it didn't go red hot. I would say it got to about 75% of its heat, and I was watching it with my infrared camera. So I have that recorded, but I never did a video to show it. So
right, we were discussing it was exhibiting properties of being a superconductor without having to be super cooled like a superconductor.
Yeah, and the coil itself was cold. Like, you could touch the coil. It should have been hot. I'm using 900 watts on 20 gauge wire. Should have melted the circuit. No.
Right, that's cold electricity.
Yeah. So,
well, as we suspect.
Yeah, exactly. It still has to be extensively tested by multiple other people. Right now, it's just me presenting it.
This is a really cool system, Gerald. I really love your work with the coils.
Thank you.
So this one said repulsion, Gerald. There's another one too.
Yeah, the repulsion one, I show it throwing the neodymium around, right? There's another part where I put it under the coil and it actually shoots it out of frame, I believe. Did you need to? I was going to shut my camera off for a second.
That's why we wear our PPE. I hope you're wearing some safety goggles or a helmet or something when you do that.
Yeah, I wear safety goggles. Usually I wear gloves, but in these videos I just didn't care.
Sometimes they get in the way too when you're trying to be precise with your.
When you're doing wiring.
Exactly.
Okay. Sorry, guys. My
oh, that's cool.
Washer and dryer downstairs, and my daughter's doing laundry. So.
Oh, you're good.
Oh, hold on, that thing just levitated. Give me a second.
Yeah, that's cool.
And that will only happen with a load.
Wow.
Oh, that's so cool.
Yeah.
So you've got that toroidal field that's surrounding the coil, basically, right? As you said, it turns into one field around the whole thing. I remember reading years ago, Harold Aspden, he was a British professor at Cambridge, I think, and he did some experiments where he rotated Leyden jars. This is back in like the 40s or 50s, I think, and he found that after he had been rotating it for a period of time, it would be easier to start up the next time as if there was a continuous fluid moment. So if you're spinning the ether, let's say, or 0 point, whatever you want to call it, if you're creating a movement, it actually has inertia, it seems, or potentially has inertia in it that actually keeps it there after you've stopped. You know, and maybe that's why your coil was still active, because you know, if it is like a superfluid of sorts, then, and it has inertia and it has movement, then yeah.
And if we also consider the
activity, wasn't it 5 minutes after you'd stopped?
Sorry, say that again.
I remember you showed a video once of your coil that when you stopped running it, it was still showing infrared activity about 5 minutes after you'd shut it down.
Yeah, and it wasn't, and that's the funny part. It wasn't heat. You could grab the coil, and the temperature on the gauge of that camera showed that it was room temperature. But yet I'm seeing on the infrared camera the full coil, and as if it was not hot, but as if there was energy flowing through it. So yeah, that's
right. If we also consider EVOs as well, EVOs have the tendency to stick around a little bit after, you know, and they also have the tendency to steal the heat, steal the heat around them. So that might be able to account for cold electricity. I'm not sure, but.
Well, I give a tip of the hat to Nathan on that one, because I never considered temperature to be any sort of factor whatsoever, but it is.
Right.
Excuse me for 1 sec, guys. Sorry to break up the conversation. I got to just deal with something really quick. Okay, so I apologize. Excuse me for a moment.
My Graviflyer gets the same thing. It's like 70-something degrees, you know what I mean, on the center plate. And then, but you touch it and it burns your finger. It's the same thing he's doing.
Yeah, it's cold electricity. Well, it might be cold electricity.
Yeah, Gerald's getting more of a vortex, though. He's getting that energy to flow in that direction.
Right, he's condensing it into a point.
Yeah, it's the way that coil's built that's doing it. We're all kind of getting a little bit, you know what I mean?
Mm-hmm.
He's getting the full effect with that thing.
Right. No, that makes sense. The closer you get to that field geometry, the natural geometry of the universe and free energy flowing, the toroid shape.
Natural geometry of the universe. I believe that 100,000%.
Oh, yeah. The theory that our universe is shaped like a torus and we're on the South Pole expanding. We can't see the implosion side and the top. Yeah, it's fascinating.
Can you see this here?
I was wondering what that was.
This is how the visual that I get from my coil when it's working, when it's running. So it's like I pinch the fields and I split the energy. So there's charge separation. You got your north blue ball, your red for yourself for a red ball, and they're chasing each other, right? Wow. As the vortex comes down, you have to have 2 points of energy that it's chasing. So it's like chasing each other in the center of the core, and then on the outside it's pushing that energy out because of the way that it's pinched. Okay, right. So you bring up the natural part of the universe, and I gotta tell you, in a dream, this is what I was shown. Give me just a sec here. So it's like okay. I know it's crazy drawing. I'm trying to do it quick and I can't do it justice. But in what I see, this being the North Pole, this being the South, our universe is a toroid. This would be our sun. Bad color, I know. But as it goes around our equatorial plane of our universe, it's going up into the upper part of the plane. And then after so many thousands of years, it's going below the equatorial plane. And it does that consistently as time flows. And by doing so, it creates a polarization, this being the north, this being the south. So if you had a way of mimicking the natural flow of the energy of the universe, you could essentially open a portal if you had the right number and end up anywhere you want it to be. Just a theory.
That makes sense. That makes sense because, in my opinion, the universe is just nothing but fractals. You know, it's fractals of itself. And if you zoom in or out on a fractal, it's relatively the same pattern, and that's what we see in nature a lot.
I would agree. I would say that the stars are fractal energy that's flowing. That's what we see as we see them sparkle and move throughout space. I think they're definitely held in space. I believe that planets all have their positions, but I think they're positioned due to the external magnetic fields of each planet that's in sequence or close by. Just like as if you were to hold two magnets close together, but they're in opposite poles, they push off each other. They're not going to slam together. They keep a certain distance. Well, if you had all that in a circle, you could actually keep certain magnets at a distance, right? So it's just a thought, just a theory, something to, think about.
It makes sense. Like if we see, magnetism and particles and then, like actual material that we can see, and then we zoom out on that scale and a larger scale, it's not unreasonable to believe that a universe would have a polarization as well.
And I can be totally wrong. Like I said, I've been wrong before. Prove me wrong. Hey, I'll admit it. So yeah, that's
there's also the consideration that apparently it's become sort of an academic fact that the universe is 99.9% plasma of different types, of different temperatures and different everything, and it's like mass and matter are almost like a little accident that happened out of the plasma, and plasma forms its own dust, and it's interesting because it goes on about it's a book I read recently by Robert Temple. It's called A New Science of Heaven, I think it's called. It's really fascinating because its work is based on academic research, not just his kind of theory, but it was all to do with the Kordylewski clouds being that there are two of them, but they're 9 times the size of the Earth, and they're between us and the moon, and they have every property that would actually allow them to be intelligent, not in organic forms. So, and they've been around billions of years or longer than us. So maybe we're just an experiment of theirs.
I get that. And I totally understand. I read maybe 2 academic papers a day, depending on the subject. But I only have half faith in academia. When they canceled the ether and started calling it the quantum vacuum, I kind of lost faith in the fact that when they predict new things, there's half of the equation missing already. So how could they be dead on? How could they be absolutely accurate when they negate half of all energy equations? And hey, don't get me wrong, I give them kudos. There's a lot of people that put a lot of life stock into their research. but I think they unfortunately took a misstep somewhere along the way. Need to pull it back and have a good look at it. It's my
Oh,
opinion.
totally. I totally agree. It was just that Temple's book was actually, he was pulling data from people like Bostic and, you know, the
Oh
people
yeah,
who really did the foundational work.
yeah.
And also via biophotonics as well. All
Oh
those
well,
things
there
that
you
have been really suppressed over the years. But he did incredible research into it and actually brought all these other papers forward, and basically as a record for the information that should be freely available. But he's had to search hard for it. So it's
go. And
really it's fascinating.
what was the name of the author?
It's called Robert Temple.
Yep.
And it's a new science of heaven is the name of the book.
Perfect.
It was
I'll
actually
have to look into that. Maybe I'll order it. I'm always looking to expand my awareness by far.
yeah.
So I'll read the book, and you know what? If I overstepped my opinion, then I'll apologize. You know what I mean? So yeah, you give me something.
I know.
Thank you.
Yes. Yeah. No, I'm totally with you. I understand exactly what you're saying.
Cool.
You know, there's a lot missing out there, really.
Well, I don't think it's for lack of wanting to research it. It's just unfortunate that in academia they get pushed down certain paths because that's where the funding is. It's no longer about the search for truth by using science, and I mean science through experimentation, because really that's what true science is. It's not writing a theory and calling it whatever you want to call it. Give me something that you built. Give me something to back that up. Show me something that you're doing that physically can show your effects that you're talking about. And unfortunately, with the academic community, I haven't seen that. And with multiple different universities, they have embellished on some of the research. But there is a lot of people out there that give their heart and soul into their work. It's just, I think they're looking in the wrong direction. And I think if they were able to get funding for what we're working on, we'd be leaps and bounds ahead of where we are today. So I don't spit on all. I think there's a lot of geniuses out there. They're just unfortunately controlled geniuses.
We also have a few very stubborn people who refuse to just acknowledge new science like the ether at all. You know, they're just too indoctrinated, and they're too far gone to be, you know, even dealt with, in my opinion.
Well, it's kind of hard if you've based your entire career researching specific things in specific ways, and then somebody tells you, actually, that's not the way it works.
Right, it shocks the fundamentals of your whole.
There's a lot of reluctance in there to change your mind when you've spent your entire life's work is based on, on something that may not have been as correct as you thought it was, right? So I understand that as well. So you get a lot of intransigence because people don't want to think out of the box when it's upsetting their apple cart, you know. So
yeah, exactly.
I mean, which is just human. That's just human nature as well, you know. But the funding is that's the big thing. Nobody can do research into what they would really love to do because they find an anomaly. They go, oh, I should look down there. I mean, that's what science is supposed to do. But if they can't get funding for that project, then they have to look elsewhere, and they need their tenureships. They need to keep feeding their families like everybody else. So they're kind of stuck in a hard place, really. So
I harp on
abilities. It's just through lack of opportunity, really.
Yeah, it doesn't pave the way for out of the box thinking. The system, you know, it's kind of stomps it out in every aspect.
Yeah, you'll see me.
We do it, so I'm sure they do it as well, but they just don't have the opportunity to really do anything about it.
Or they don't want to put their funding.
Right? No, yeah, exactly. Yeah, there's not going to be any serious development from it.
Like you'll see me harp on academia, but I won't harp on individuals doing work in academia because they're doing what they believe is right. You know what I mean? I may not agree with it, but I harp on the system because the system is broken. The people in it
exactly
just
right.
do what they think are right? You know, so
that's exactly right.
When you hear me harp on academia, it's on the system. It's not on the people. just
right, guys.
Oh yeah, no, this is your this is sitting on the magnets, right, and levitates it up. as you connect each circuit.
All right, Gerald, it's all on you, buddy. I'll hit play.
So what is this a similar weave to what you were using in your main coil, or is this a different? It's just a
This
different
is a
manipulation of
different
the
weave.
fields.
It's a different weave, and it's a lot less. Let's see. This one's 12 feet on either side bifiling. So it's 24 feet in total. That's it. And it's made with 30 gauge, I think, or 32. I can't remember. It's almost as thin as a human hair.
Right.
Very hard to wind. When you pull on it, it breaks. So it was very difficult. But the basic principle is still the same. And the winding sequence was slightly different than you see in that big coil.
So what exactly is going on here?
I'm pulsing my primary. I can't remember how much. I think it was 1,000 hertz on that one.
What we have here is two modified Joule thieves, both being using this 12-volt battery, which, as you can see, is fairly dead. We have a function generator pulsing at 1,000 hertz, 10% duty cycle, square wave. Both channels are going to pulse at the exact same pulse rate. And the first channel is going into the primary, and the second channel is going into the secondary. And what we're going to attempt is to see if we can raise this coil not once, but twice. Now, when you send a signal against or at each other, usually it cancels out. So let's see. The primary is turning on in 3, 2, 1. Now we're going to turn the secondary on in 3, 2, 1. As you can see, the signal didn't cancel out. All right, everybody, you have a great day.
That was so cool. That's amazing. So it jumped twice. Oh, you said the signal didn't cancel out, but the energy and everything, it's like two separate energies in there?
Yeah, well, what it is, it comes from the same battery, but it's two signals from the signal generator. Because the coil's wrapped 180 degrees out of phase, I pulsed the primary with 1,000 hertz. I think it was 10% duty cycle. I can't remember. And then I did the exact same pulse frequency on the secondary right at each other. So normally in a system like a solenoid, if you were to pulse a signal at each other, it just cancels each other out. And what do you get? Maybe a bit of a field or something. I'm not even sure. But mine doesn't cancel out. When I pulse my primary and then I pulse my secondary at each other, it multiplies. And so what you were seeing is I pulsed the primary, it created a field that had lift. Then I pulsed the secondary and it raised even more. So that's what was going on there.
And is that just sending the opposite polar magnetism to the magnet face, and that's what's forcing it up? Is it repulsion?
I would say it's repulsion. Whether or not it's magnetic current that's pushing it up is debatable, because when I pulse those coils, I lose magnetism after 20 hertz. At least evident magnetism. That doesn't mean that there isn't a magnetic field there, but a magnet isn't affected by it when it reaches above 20 hertz. It'll polarize, and then it just sits there. It doesn't turn, it doesn't hum, nothing. But if I turn the hertz down to, like, say, 20 and below, I can make it turn on its axis, or I can make it turn the other way. I can't remember the term I was using for. I was explaining this to Jeremiah Pop, and he had seen it on video as well. I just can't remember. It's like when you have North Pole and the South Pole, it's not supposed to be able to turn this way, right? Well, the coil does that. It'll also turn on its pole, but it'll only turn on its pole 20 hertz and below. When it spins like this on its axis, I can get to maybe 85 hertz tops, and then it stops. And then it's just power output from there and a high pitched squeal or sound that comes out of the coil, right? So I'm not sure, excuse me, if it's a magnetic field pushing off or if it's a scalar field pushing off, because the power is so minimal. It's just on the watt meter. Sometimes it doesn't even show up. And I'm not sure if that's the same video or not. I'm not even using the 12-volt battery. I'm just using the signal generator. So if I'm just using the signal generator, it shouldn't be lifting at all. There's not enough power to create a magnetic field at all, right? So there's obviously something else going on there. Still working on what? I have some ideas though. Yeah. So I don't know if that answered the question or not, but yeah. Any thoughts on this, Nathan, on how you think it's working?
Sorry, give me 1 second. I was over there looking something up for you.
I apologize.
It's okay. No, I think what's going on is you've created the bubble, but now it has to build on top of it. So you've already set the fact that it's there. You know what I mean? And because it's 180 out of phase, it's creating a secondary one, and it can't occupy the same space. You see what I'm saying?
Yeah.
So if you were to turn it on the other way, it would still go one, and it would still go the other, because you're able to build on top of each other. So if you put a third winding in there, did the same thing, I would expect it to jump 3 times. So if you understand what I mean, you're creating the field already, and then boom, boom, each one.
And I know you're dead on that one, because I never told anybody that I pulsed it the opposite direction and it did the same thing. I kept that one to myself.
Good call. Let it out now. Got it out of you.
Well, it wasn't a secret. It shows that you know what you're talking about. You know what I mean? I left it out because it's really not important unless this conversation was to occur, which is like,
buddy, that's one of the most important things right there. Yeah, that's like new tech right there. You got to have it now.
Yeah, both ways. It works both ways. It does make a difference. You're absolutely right, Nathan.
Well, it tells you about pressure and relationship between the coil and the magnet and what it's doing. So you think it's just one thing when you have that, right? But say if it was in a system where it's held tight, now you're causing compression in it, right? And then you get a spring effect out of it. That's amazing. I'm
already working on the third coils, 2 separate ones, so that I can do that test. Because
another set of double coils above it. So I don't know if you have to put paper in between, but you can lift on the double and then see if it'll create a field above it and lift on the double again.
Well, when I built that coil that you see lift above the magnet, I built an identical one. So there's 2 of them. So I can do that test. That's awesome.
That'd be truly interesting, because it kind of tells you a lot more about what's going on too, because the magnet's not under it this time, but the wire is a magnetic field. So will it continue to do it?
I like the way you're thinking. I'm going to have to try that. Absolutely. And while I was watching your video earlier today, something in my head clicked, and I wrote down a sequence that I have to try. I think I may have what you're looking for. Because if this sequence works, then it's the exact same thing you're talking about the Graviflyer. Identical.
Hey, Gerald, did you ever mention what frequency you were pulsing your coil at when you got it to levitate, that little neodymium disc?
1,000 hertz.
1,000 hertz.
Oh, which one, on the levitating video or the one with the disc that you just saw?
The disc that was underneath the coil, and then it kind of swooped inside and just levitated on top. That was really cool.
Oh yeah, that's the one with the load, right? That I used the element on. I believe that was. I'd have to look at my notes, but I believe that one was 20,000 hertz.
20,000. Okay.
Yeah, 20K. That one.
Interesting.
Hey, Gerald.
Yeah.
One quick thing, last thing on that little coil, okay?
Mhm.
I'm interested to see, because it's not a magnet, if it jumps off. Okay? If it jumps up from that next angle. And if you change the coil direction, would it matter? So we're looking at a coil wrapped this way, right?
Oh yeah.
What if it's wrapped, you know what I mean, like this?
So it's like a wheel and a wheel.
Yeah.
Like a gyroscope.
So would it get a longitudinal jump? You know what I mean? Would it shoot straight up? I don't know how to build that exactly, but I'm just.
I do. It takes a while though. The reason why I never built a coil like that, like I tried at one point. I'm sorry, Bogrish, your name is Ian? I apologize. Ian? Okay. So Ian's kind of doing the same thing that I did at one point. You wind your coil and then you reverse the winding. And what I was trying to build was like a hourglass figure and then a circle that goes around it. So it's like a sphere with an hourglass in the middle. It's very difficult because the form you have to build to wrap it, it's insane.
Right.
So
the hourglass is the indent for the toroid.
Yeah, well, on the inside.
The negative image. Yeah.
Mm-hmm. So I don't know if I can make that, but I'll try.
So hold on. If you do an hourglass, you would basically have to have, as it goes up, the hooks would have to go out, and then the other one would have to loop into it. You know what I mean? Like you're sewing in order to bring it around. That'd be the only way to get the two to combine, because one wire for that whole thing would be insane.
Yeah, I get what you're saying by that. That's kind of like in one of my videos, you'll see I take a ferrite core. It's broken in half, and it's got 100 wraps on one side and 100 on the other. And I clamp it over a smaller toroid. And then one coil has a diode and a capacitor, and the other one, goes to an LED. Like not just a small one, like a whole bank of them. And sorry?
No, I'm sorry. I didn't mean to interrupt.
Oh, it's all good. And then that very clamp, like I can pull energy out of that all day and it doesn't affect the watt meter whatsoever. So, but I've never tried pulsing the two like you're saying. So that's interesting. And
I was also thinking,
you got me thinking.
Nathan also got me thinking, do you think we can 3D print like a frame for like the hourglass shape for the coil? Like maybe like a sliding disc frame like we see with the PoE vortex coil?
To build an hourglass coil or to build my coil like I misunderstood.
To easily wrap the coil in an hourglass shape instead of a torus shape like we see with the PoE coil. You want wrap it in an hourglass shape. Yeah, like a frame. To make it evenly spaced.
It has to be it has to be a triple frame. You'd have to have a plate up above. You'd have to have a plate down below, and then you'd have to have a plate in the middle with a hole that you can wind your copper through, and your number sequence wouldn't go in a circle. Say you go 1, 3, 5, 7. It would go 1 through the hole to 3, through the hole to 5, through the hole to 7, and it would be consistently like that. So your pinch would be like a kind of like a hard twist. But at the same time, all the upper part would come out and it would form a geometrical form up above and it would form a geometrical form below. But your copper on the inside of that hole on your center plate would be like a compressed twist. I built one half done prior and I chucked it because I didn't have the patience to finish it.
Well, what was your method for building it? Did you have like a frame or did you wind it around something?
What I did is I had 3 pieces of, I think it was 1/4-inch plywood. And then I had the form on the top, but I had a big hole that was right around where I had the nails put in. And then I had a middle plate with a smaller hole. And then I had a bottom plate with the nails, but it also had a big hole in it. So I was, and to hold it all together, I was using threaded bolts with nuts that held each plate in place. So it was kind of like a scaffolding, right?
Mm.
So it looked like this big 3-plated, huge monstrosity. It was very difficult to wind, but it is possible.
Huh.
Yeah. I could build something similar to show you, but it might take me a couple days. just to build the form, right? So that
that sounds very complicated.
A little bit. It'd be easier for you to take a 1/4-inch or a 1/2-inch copper tubing. You know how it spirals? So you pull it apart, and then you would take bolts, and you would bolt bolts around it into a board, and then you would fit that copper tubing around that, and you would wind around the copper tubing. It would be a lot easier. In fact, I bring that up because that's the one I've almost completed. And that one's for, I'm going to attempt to heat water while pulsing the toroid coil, because the copper tubing is wrapped within the geometrical coil itself.
Oh, hold on. Ian's got something like that. Give me a second. I'll pull it up for you.
See, I was wondering if you had more coils than just that one.
Oh, he does.
Oh, I like this. Now you get me all happy. I love seeing geometrical coils. They're the best. I'm down.
So hold on. You're talking about the inner coil. So let's pull that up. So there's the inner.
Nice.
Oh yeah, I was going to cook my dinner on that. Yeah.
Yeah.
No, that's a tune. That's a primary coil for there's a pancake bifilar coil underneath it, and I was using that just to keep it all flat. So it's for the Graviflyer, basically trying to. I could be, completely in the wrong direction, but I'm trying to use the ZVS impulsing into it. Oh, question. Why? Let's see, where are they? Every time I remove the capacitors, both sides of it short out. And is that because I'm blowing something?
I'm not a ZVS guy yet.
I've never had it short out when I remove the capacitors. How are you removing them? Just soldering them out?
Just soldering them out, and they're nowhere near the components that I can't think why I'd be blowing the MOSFETs with the heat, but anyway, it's not just once; it's happened twice. So I cut everything out around it to make sure that there wasn't any shorting or anything going on. And this was a new one I got yesterday, and I took them out and it shorted immediately. Totally bizarre.
Did you run it without the new capacitor put in it?
Nope. There's no point, because I know it'll just go straight to 10 amps out of the power supply, and it'll do nothing. But I have another smaller one which I've used it to tune the coil anyway. So until
what's the capacitors that you're adding to it?
Oh, these. Well, that's tuning board I made. So it's a 6 kilovolt. So it between that. Yeah, just using a small ZVS board, and then that feeds into the capacitors, and then the capacitors go to the primary, to the tuning points on the primary. So, basically, the ones with switches, when you go over like 1,000 or 2,000 volts, you start getting zapped with the switches. So these are just like hard points that I just basically put in put in wire joiners in between them and just screw them down, basically. So, but it works fine. So I mean, that coil, I mean, it was tuned at I think it was 71.6 nanofarads, basically it was.
So is that coming out of the ZVS right there? That those units are before the ZVS, right?
No, that's to replace the capacitors that were on the ZVS. I got rid of those on that one, just as a stopgap, and then that's a tuning capacitor bank, so I can get to the exact best tuning for the coil pair.
probably what's
make
doing it. Because we're just using 2 capacitors, right? At 0.150 nanofarad. So together in series, we're getting 0.075 nanofarads in the capacitance, but it's not variable. So it's a direct shot. So it doesn't have any feedback. My thought is with that variable, you may have feedback. And as soon as you get feedback on the ZVS where it's not protected, it blows it.
Yeah.
Right. But it's not, I never actually was able to do anything with this. I haven't even tried it. I just know that the posts are shorting out, so it's not going to work. And that's just from removing the capacitors that were on it. I haven't even connected it to the coils or anything. So the capacitor, the tuning bank is basically, I mean, they're polypropylene, so they're fast switching and all the rest of it. And then the more capacitors you have to do the same thing, the ESR goes down as well, so you get a better flow through it as well. So
did you short?
But only the ones that are actually connected are actually active in it.
Did you short the capacitors before you unsoldered them? Because I wonder if they tested it at the factory and it had a charge. So when you went to unsolder it, it shorted them out.
Ah, quite possibly. But have you ever had to do that, Nathan, with your?
I didn't have any problems with mine. I put a flathead screwdriver in between the capacitor and the board, and I hit the solder on the back and pop each side one at a time. I never put it on a flat plate or anything like that, a hot plate. I can have Sean get with you right here. Sean, absolute expert on this. Walk me through everything. Trust me. So he'll explain it. Yeah, because that way we can stop blowing these things up and get you on to the next level. So I'll put you in direct contact with Sean, and I'm sure he'll help you out.
That'd be great. For sure.
Yeah. He's got some awesome Tesla coil stuff. Sorry, go ahead, Don.
No, I was just going to show. I literally just wind these just to go above and below. I don't know. I mean, in the Graviflyer, I mean, again, I'm just trying to work with the same principles that are already out there. But I was trying to using Evo circuits where I can actually impulse these coils. And I went down a very long conversation with ChatGPT about the coil winding directions, the field directions, and just to get everything congruent going through from top to bottom. And even the orientation of the magnet bowls I was using, it's like those primer bowls. I made a few of those north and south.
Oh yeah.
But basically, there was with the ribbon coils I used, there was too much interaction between the coils. They were feeding into each other all over the place. But that's because I was using different pulsing. I wasn't using the ZVS. But that's why I wanted to make this center coil here, which is a pancake. But basically, I had to use neodymium magnets to hold it together, the former together, to stop it from doing too many multiple winds on each surface. But I'd actually, interestingly enough, I don't know, Sean might be able to answer this. When I had the neo magnets on it, holding the former together, the resonant. I was waiting for the epoxy to dry, and I thought I'd do some measurements on it. The coil came out at, I think it was 290 kilohertz as its resonant frequency, and when I took the magnets off, it dropped to 190. So that was kind of weird. So I guess the magnetic fields were interacting with it in such a way that it was. You'd think it would have sent it the other direction, but it reduced it by a third, and that was kind of weird.
Slowed the field down, perhaps.
Yeah. Well, it was. I mean, it slowed down. It made it as if it was a bigger coil. Basically, it was slowing down the resonant frequency.
That makes sense.
Yeah, but yeah. No, I've tried a few things. I mean, this one I made just because it was a it looked like it should be something of great beauty.
The
And it is,
POE.
but it has a nested coil inside it, which is, I mean, it's a Rodin coil, but it's the first and third order. I made a smaller one of I got a
Hold on, can you show that at an angle? Because we can't see the coil in the center of it. Oh, there you go.
oh well
Oh,
you
yeah.
can see this one. You
Now
see
we
the
see
one
it,
that's
yeah.
over there.
There it is.
Yeah, so it's yeah.
That's a big
But they
rodent.
also
Did you get that
Yeah.
frame design from Alchemical Science?
No, I did it before him, and it was
Oh,
there was a guy on oh what's that website that has all the anyway it was Tom. Oh, it was 11 years ago, I think, but I found it about in 2019. I think I built this, and that was the first coil I made. So
maybe Tom
this
Barnett.
one I made
But
as a Tom Barnett. That's it. Yeah, it was Tom
Yeah.
Barnett's his entire kind of take on the whole Mod 9 and the whole sequencing was
that's a beautiful coil.
somebody actually somebody designed all the formers that you could make to make that coil, and that was I think why I bought the first 3D printer was because of that. So, but
How difficult was that to wind that nested coil? Did you have to wind the outer coil first and then
This
the
one?
nested, or vice versa? No,
yeah,
the bigger one.
Yeah, you've got the bigger one. Well, they're both the same principle. So I put some other coils of just heavy number 8 gauge inside both of them, orthogonally to them, just to see if I don't even know why I did that at the time. It just seemed like a good idea. And now I'd be able to impulse those as primaries and see how they would behave with the.
Have you
with
noticed
the
any
other
over
coils
unity
conductively.
effects?
Well, hello.
No, hey.
Loving your
What's going on,
coils.
Bernie? How you
Hey,
doing?
Bernie.
Loving all the
Yeah.
coils.
Yeah, the coils are beautiful. I love them.
Well, this one has the most amplification just from its own resonance. You know, when I put them in series from the outer to the inner, I mean, it's up. It's like 5 megahertz or something like that, but it's or less. I can't remember. I wrote it down, but it goes from a 12-volt input. It'll be up at 300 volts at its resonant frequency as well. So
While maintaining the
it's
amperage.
nice.
Nice.
Well, it's just purely the signal generator going into it, so it's resonating at its self-resonant point, but it raises. I mean, it just jumps. I mean, it goes way up on it. So it's,
Yeah, no, that's
nice.
interesting because I noticed the same kind of effect in my vortex coil. I've got a PoE vortex coil with the interference pattern, similar to that one, only
Right.
with the interference pattern. And we got it to double the voltage while maintaining the current on the output side, which is
Right.
pretty extraordinary. But it's not that extraordinary when you look into the research of these coils. That's what they're supposed to do.
Sure. Yeah. I've only done voltage impulsing, and I'd like to get into doing proper current impulses, and then to see, because that's I mean, with Evo's last video on this, I mean, he's helped me immeasurably in everything with the circuits and everything. I'll take my hat off to the guy; he's brilliant, and so he's, we're talking about what Tesla's radiant energy really is. It's basically that's a current. It's based on rapid discharge of capacitors, basically.
Impulse.
He also said that the CVS cannot produce current impulses, and he's usually right, but I don't understand that at the minute. I'm not quite sure.
So, are you familiar with the work of First Stop Energies at all?
Yeah. Oh, I had a good look at it before, and I made these instead of the PoEs, simply because they'd obviously been around for a while. And there was one video that I've never been able to find again.
Oh,
there's one video they did that I've not been able to find, and that was
all of their videos have been taken down. They're like impossible to get a hold of.
Yeah, but there was a great one, and it was all to do with he was inputting that tonal frequency into it, and it was quadrupling in intensity, depending on which. And I do have in the notebook. I actually took notes on it because I was interested because it was to do with acoustics basically rather than anything else, and it was very responsive to that as well. But I've got them somewhere. I haven't been able to find them recently though. But yeah.
The reason why I bring it up though is I wanted to ask you if you're using or if you've ever used or intended to use the Nunez method, the open circuit method that they employ in some of their designs. Or are you familiar with the open circuit method that they use?
No, I didn't.
Yeah, I'll show you.
I looked at it. Okay, sure. Yeah, I mean, once I saw Gerald's coil, I thought that's the way to go.
Yeah, I appreciate that.
Yeah.
I want to teach everybody, so I'm glad you're interested. That's awesome.
Oh,
definitely,
totally, yeah. No,
you're definitely going to have to be in on that class that we teach. So what's been?
I'll be there for sure. Yeah.
Awesome.
Okay, so 18 kilohertz. Okay, and what sort of results did they get with this?
So they claim that with this open circuit method, it maximizes the resonance within these vortex coils, and they're able to 10 times the voltage output while maintaining or slightly increasing the current. I've actually seen a spike of energy at some of these higher frequencies. I can't actually use the higher frequency ranges with the setup I have. I'm kind of limited, but because I'm using a stereo amp receiver basically to input the power and the tone. Right. But yeah, no, it's an interesting method, and not a lot of people are aware of it. So I tried to reverse engineer what they were doing because a lot of stuff got taken down, and I put a guide up, a do-it-yourself guide, if you're interested in the open circuit method and learning more about it.
Right. No, for sure. Yeah. No, it's interesting. Yeah, because I remembered Marco Rodin, as colorful a character as he is, he did that. He had what was that guy's name? Guy always wears the hat. Anyway, he basically did a reverse engineering project for Marco based on a video that they had, a live presentation of stuff. What was that?
Randy Powell.
You know the one?
He was the one who, he was the one who originally transcribed VBM on and put it, mapped it onto the Torrid for practical uses. And his work is actually what we're seeing a lot of in these coils, or remnants of his work.
Yeah, Randy Powell followed Marco Rodin for quite a while after Marco Rodin kind of fell away from.
All right. No, but this was a different video, and it was a presentation, like a live presentation with this guy who was in Germany or something, who had wired the coil in a specific way and using it in a bass amplifier. But I didn't really know enough about it to understand it properly at the time. But he was using a bunch of high voltage capacitors, and he was creating what seemed to be a lot more coming out than was going in, to the point where Marco Rodin actually asked, it's the guy who makes the model airplanes and stuff now. He has this kid called Charlie. I wish I could remember his name. Anyway, but he did a lot of work in reverse engineering that, but he could not find a way that it worked. And so that all kind of went away. But it was but it was more on this design of coil, the continuous spiral, rather than the cross weave that the PoE coils are. But it's interesting. I mean, I've definitely,
So
I keep getting distracted down rabbit holes, and then I don't quite finish this one, and then I'll move on to this, or I don't experiment enough with this one, and then I think, ooh, that looks really interesting. I think I'll go there. But that's what I've done with your coil, Gerald. It's like I'm really fascinated by it because it's great. I mean, the fact that you've got that geometry and the rhythm all built into the coil is just awesome. Really good. Yeah.
So First Up Energy was actually using the coil that you use without the interference pattern, the design without the interference pattern, to drive rotaries more efficiently. And they were doing testing with that versus the interference pattern. They found that was the more efficient one to generate the magnetic field to drive the magnetic rotary. And I have videos on my channel of clips that I found on. You can actually go on their Instagram. The Instagram is the one thing that they have left. A lot of video clips of their experiments and stuff is still up there, where they're driving a bunch of different rotaries with different sizes of these coils, and it's really impressive.
All right. Do you mean I have to join Instagram?
Oh no. I honestly I feel you on that, but no, you don't have to join just to look at their videos. You can just go to First Stop Energies Instagram, yeah, and you can see a lot of.
Right. Okay, so they're still around then. Well, that's good. Okay. Yeah, no, I will do for sure.
One Stop Energies. That's the Nunez couple, correct?
The Nunez, yes. The couple, we don't know what happened to them. They stopped communications late in 2022, early 2023. So they kind of dropped off of all their social media platforms went silent. So, but in terms of the information that's still left, their YouTube videos got pulled down. They had hundreds, but you can go to Instagram and find some of the remnants of that. And I did actually, in the do-it-yourself guide, I did manage to pull some of the screenshots of their website, which they had a forum link to in their website that the link was disconnected. But I found a connection to it while doing a Google search. You know, sometimes it brings up different pages from the website. And so I don't know how I found it, but I found it, and it had like a whole bunch of descriptions of all the videos that were taken down off of YouTube. So I managed to grab all that, and I have that documented as well.
Nice. Yeah, I heard whispers of they got snatched up by a private company, but again, just whispers, you know, take it with a big truck of salt. So who knows? Like you said, they just sort of.
I have no doubt that somebody, you know, wanted to use them for some kind of you know, project or another. So yeah, it could be.
I'm still trying to figure out how to get a rotor apart from a car alternator, because when I do, I've got a circuit that I believe once I put a bifilar coil inside that rotor, that the alternator will run itself. So it's just a thought. It's an experiment I've been waiting to do, but yeah. So
that's going to be a fun one. I can't wait for that one.
Yeah, that one will be interesting. Whether or not it does anything, we'll see, right? But we should all keep working on the stuff.
If the coil is putting out cold electricity too, and you hook it up to the car and it's going to the battery is going to be rejuvenated every time, you know, it gets a pulse of that energy. So, so that's wow. Yeah. That will be revolutionary right there if you can get that working.
Yeah. Hey, Ian, you want to describe these coils here and what was going on?
Oh, these were the first ones I made for the Graviflyer, because I wanted to have tons of capacitance built into the coils naturally themselves. Mm-hmm. So I used I saw that Australian guy made a small one, and it's really low resonant frequency naturally, and I thought, oh, I'll try and use these first, but boy, they are tough to make. So I made that jig, and you just basically, the tape is its breakout voltage is 6 kilovolts for each layer of tape. So I put down 2 to get 12 kilovolt separation between the windings, and the rest it's just bare copper tape. So, but you have to get it bifilar, you have to run 2 tapes at the same time, and then 4 rolls of the insulating tape, and it's difficult. It is difficult. That one was going well at that point. But I did manage to get them all done. But as soon as I put them into the Graviflyer and I was trying to keep the current as low as possible, because I knew it was going to be a problem if I went over an amp. And I was only at about maybe 300-400 milliamps, and the heat had nowhere to go. And the coils were starting to buckle inside the formers that I'd encased them in, and it was just like, oh, okay, that didn't work. So that was I should have known, but you got to try, right?
Fascinating. That's fascinating to see the ingenuity to put that together.
That's awesome.
Well, you had to get the wrapping exactly to the millimeter right. You had to have exactly the right little guides there, so that it was lifted at the right point above the lower frame, and then the tape had to be a different height. And so anyway, I spent a few weeks doing that, and I was disappointed when I've still got the big one in the center, and it's still in good shape, kind of thing. But the others, yeah. But maybe if we end up going cold, then and there's no amperage going through it, then it may show some interesting properties at the end as well. Which is
I'll go ahead and pull up your other one as well.
How else do you know unless you try, right? I paid 175 coils, but not all of them worked. So, you know, it just is what it is. That's experimentation. That's awesome.
Yeah.
Don't ever give up. Don't ever let anyone tell you it can't be done.
Yeah. Oh, that's one that I got. That's like 140 millimeters. So it's about 14 centimeters. In fact, it's a little bit more than that. That's as big as I could make the former on my printer. Let's put it that way.
Yeah.
But it's really tough though. You've got to end up turning it physically with your hand in the center rather than that center point, because the center point that the tool tends to break because there's so much torque on it now when it gets bigger, but also that it causes the internal rotation to contort, and it kind of starts to display kind of weird behavior, and then it starts to bulge up in different places. Yeah, that's difficult.
That is difficult.
I won't be going there for any particular reason in the near future. Anyway. But it was fun. It was fun to do and to see it. But, yeah.
See, it's amazing what you learn from that too, right? That's
the
stuff that I've done.
There you go. There you go. That was perfect the night before, and I got up in the morning. I looked at it, I thought, what the heck happened to that? And
just too tight. It exploded on you.
Yeah, it didn't like what I did. That's for sure.
That's funny.
Yeah. Yeah.
That's absolutely amazing. That was so cool, man. I just love the ingenuity to go to one coil to the next, you know what I mean? Try them out, see what they do, and keep building.
Yep.
Yeah.
The amount of Go ahead.
Yeah, because the Graviflyer I was hoping that I would be able to get enough electrostatic energy out of them, but I mean the inductance was way too high basically. But so then I was being able to feed off the same circuit, which was Evo's radiant power circuit. I reckoned that I should be able to take some of the stored energy that was going into the capacitor for recycling back into the system to go back through the MOSFET. I was taking that, feeding that off onto basically just like curved metal surfaces made of foil on the top and the bottom. So I was getting the positive on the top and the negative on the bottom, but I couldn't. That circuit didn't work. I got to go onto the flybacks to get that kind of energy that I need. It didn't. It was a couple of 100 volts was all I was getting of it.
From my experience, if you want to take your back energy and you want to put it back into the front part of the circuit, you have to have two separate circuits before you link it. It can't be from the same circuit. It'll never work. The resonance cuts out. I don't know why it's like that, but it just is.
Well, in this case, I was pulsing. I was a positive impulse going into the top with a DC offset, positive DC offset to get it raised up a bit higher. And then on the bottom, it was a negative impulse with a negative DC offset again for the same reason, to get as much pressure difference between the top and the bottom. But the problem is that the coils inductively interfered too much together. I couldn't, and it didn't really matter how far I separated the top and bottom ones because I had movement there. And then also the magnetic field was too strong. Those neodymiums in those bowls at the top and bottom, they were oriented correctly, but they, I was hoping that they would cause some kind of movement with the field around the coils. But then pancake coils are very good at holding the magnetic field very close.
They are.
So it's difficult there as well. So, but I thought that would work for electrostatic, but it didn't.
Well, like I was going to say before, it's all about the experiments it takes to get to where you're at.
Yeah.
I got like 12 binders of notes on all the experiments I've done. And I mean, fat thick school binders, because
Right.
it's not the experiment that worked. It's the 1,000 experiments that didn't work that brought me to the one that did. Right. So yeah, keep at it. That's your setup there.
That's
what's going on here?
That was an earlier one. Okay, this was me just taking a dive into acoustic resonance and mixing it with electromagnetic resonance, right? So those the coils there, those are two solenoid coils. One is inside the other, and there's a primary. I had actually ended up with primaries on both sides, so I was just inducing, but that kind of didn't work. But basically, those are resonance speakers that are. I joined the coils onto them using little 3D printed cups and epoxy, so when the speakers would vibrate, they would physically put the vibration into the coils, and that's before I saw Nathan's low voltage method of actually putting those frequencies into the coil through that back door, as it were, kind of thing. So I was thinking, well, the only way I'm going to do this is to make coils that are going to vibrate physically, and also be able to adjust the frequency going into them. And that those coils, those are the ones that the complaints immediately started, because they vibrated, they resonated perfectly at about 7.5 kilohertz. And it's like, it was horrible to listen to. But
did you manage?
But I tuned them so that I would then get a different octave or a different harmonic of that resonant acoustic frequency into the electromagnetic frequency to see if I could get any anomalies coming out of the coil. I was looking for parametric excitation or something to see if the physical vibration of the acoustics would interact somehow with because historically this seems to have been a common theme in the distant past, where acoustics are used to do all manner of things. So I thought, well, I'd have a look at this and see if this did it, but it was complicated because you're monitoring the resonant acoustic frequency using those little microphones that are hanging off the clips, and then electromagnetically impulsing the coils again with voltage impulses to get the resonance for the coil as well. Those are the tuning capacitor banks on the left hand side. That's the red container ships, as my wife calls them, and then
that's that master Evo
DI box. Yeah, and then there's DI boxes to transfer the signal from the signal generator in through an amplifier and then into the that's right, then into the speakers. There was impedance issues, so I had to use the DI boxes and stuff to be able to cope with that. And then I ended up, after that, I found that the amplifier I was using, there was bleed through in the channel, so I couldn't separate it out properly. So I ended up getting a small mixing board and sending it through there first and then out into the amplifier afterwards. And that kind of cleaned it up a bit. But I couldn't get any anomalies out of it. Let's put it that way. It didn't kind of work as I intended it to do. But yeah, now that I'm not limited with coils that are rigid enough to physically vibrate independently of each other, I'm really keen to get this circuit that Nathan showed, just using the little add-on board. Although it's only good to 20 kilohertz, but it's if you're working in acoustics and harmonics, and that should be good enough anyway for what we're trying to do. But it'd be nice to be able to do it with ultrasound as well, applying the ultrasound directly to the actual coils. So yeah,
that's different. I've never seen sound tried to be used that way. That's unique. I should try something like that. I've done it with a flame, but not like that. Like interesting.
Well, that's as mandrolic as it gets, really. It's just basically physically vibrating.
Yeah.
They're actually, but anyway.
But again, you never know.
We take a different design.
Well, I did a weird experiment one day that I was just messing around. I wasn't thinking about it. I was pulsing the coil. I think it was like 528 hertz or somewhere around there. And I was collecting the back EMF in a LED bank. And then I took my lighter just to see if I heated up the inside of the inner core, if it was going to heat up the copper, what was going to happen. So I took my lighter and I turned it on and I just held it there for, I don't know, half a minute. And the voltage went up in my coil. And I thought that was kind of neat, but no big deal. And then I took the flame away and just forgot about the whole experiment. But it's thinking outside the box like you're doing that allowed me to understand that heat can actually be picked up in a system with a vortex. So maybe keep that in mind. And when you start doing experiments, try that yourself. Just a light flame.
Yeah, sure.
See if your voltage changes.
Right. Yeah.
So you want to take a look?
Oh,
at
yeah.
these? This is the top and bottom part that you have on that solid state Graviflyer. So you want to explain it?
Primer field.
Yeah, yeah, that's right. It's a primer bolt or primer bolt, and his name escapes me. David Lapointe.
Yes.
David Lapointe was
Lapointe,
the guy who designed it.
Yeah.
Is it Point?
Lapointe, yeah.
Okay. Okay. And so basically, the magnetic field that this produces is pretty unique, and it creates a rotation naturally, because when he was using the high voltage discharge from the center, it was actually doing a very, I'd say it was like 70,000 volts DC, positive and negative on the other side, and he was placing them upside down in a vacuum, and the plasma field that formed from the high voltage discharges was rotating in the center. It looked like a little galaxy, basically. You know, it was incredible. So
cool.
I figured that if you can get rotation out of it, and I thought, well, the reason for the copper mesh is probably completely misguided, but I saw that Gerard Morin video where he put the voltage across the magnets, and it played that tune, you know, da, 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 that, remember? And I was thinking, well, if I pulse the same frequency of voltage that I'm resonating the coil beside it, and I just put a lower voltage pulse through the magnets across the surface, and there's a black insert bowl that would press all that flat hard against the actual magnets. I just took that just to remind myself which way that one went.
Yep.
So then I thought, well, maybe I can induce a rotation with the magnetic field from this and the coil, because they're all in the same sense in terms of the way the coil was wound and everything. And I was just trying anything I could to try to get rid of the spinning discs, rather than make the field spin, rather than physically spin a plate, basically. So,
well,
I know where I was coming.
I know there's more than one way to skin a cat, but when it comes to the creating a vortex, and I know there's a lot of different ways of doing it, I'm not sure if you would accomplish it with this. That's a very interesting thought. I never even considered that. I know the primer field.
Well, I never.
Go ahead.
Mm-hmm. I actually never got to even try it, because the coils distorted before I got to that point. And then I've had a couple of months of real silly busyness. So I've finally got back, and that's why I made the other coils now, which are more robust. But yeah, and looking at your coil though as well. I mean, that's really what we're looking for, isn't it?
Yeah.
It's certainly it goes a long way towards it, I think. So
yeah, Gerald's whole coil is beyond that Graviflyer. Let me tell you.
Yeah.
Sorry.
Well, thank you for that, Dave.
No. We're talking everything I need in all these mechanical parts are all in one coil. You know what I mean? We just throw the rest out. I don't need it. I need the coil. I need a piezo buzzer. You know what I mean? And that's about it. Because then you got the right frequency. You already have the coil. I don't have to mess with the Tesla coil. You know what I mean? And we have the high voltage in there because, hold on, I'll show you guys a picture in a minute. Gerald's coil is breaking out, and it's got bubbles in it. So I want to make sure Gerald goes over that. And by the way, did you run the test when you see the bubbles?
You know what? I had to finish a contract this morning, and I never got a chance to do that experiment. So that's on the list. As soon as I do, I'll send you that video.
Okay, I'm gonna pull that up.
Okay. Yeah, I'm at the stage now where I understand the coil system to the point where I can hit it with one pulse and it creates spin. So the coil itself, you could, some people refer to it as a prime mover. I don't know about that so much. And again, it has to be tested extensively, but one pulse and it creates a spin kind of makes you lean towards that. I think that's the direction you should head. But again, I'm not.
Yeah, no, absolutely. I'm not attached to anything I've done. I just thought those were the ideas I had at the time, and whether it was correct or not it's always fun. It's fun doing it, and I love doing it. So it's kind of fun. But certainly the what was I going to say? Yeah, you were saying about the when I saw those little like shiny bubbles on the coil, I kind of thought, oh, I wonder if those are plasmoids. And then I wondered if you were conditioning the coil when you were running it. And again, it's like if the field is being moved and there is inertia in that field, then after it's off, who knows how long it stays around for. And I know that at the Cosmic Summit, when Bendel was showing his engine, and somebody had completely destroyed the bubbler unit the night before, so it was broken. But there was enough plasmoid coating or the energy inside the gubbins that takes it and separates the basically. There was enough in there. It was actually working fine without the bubbler, which is actually the implosion point. So it was working just on its own. He was relieved. I could tell. You could see it because somebody completely physically took apart the bubbler and broke the seals so that he lost the vacuum in it, and he didn't have anything to replace it with. But it still worked because it had been conditioned, because he'd been running the same generator in London, I think a couple of months before, showing it. So I'm wondering if you're saying that you can just hit one pulse and that's enough just to regenerate the whole movement that's conditioned in the coil now and around it. So I don't know exactly how that would work, but it's just a thought.
When we do the class and I explain it, it's going to be like this kind of a moment, and I'm not trying to degrade my work or anybody's work who is in this field, but it was like this for me. Oh, really? You know what I mean? So I believe that once you get that shown to you, it's going to be like that for you and everybody else. It was a lot simpler than I thought. You know, kind of like the KISS theory, keep it simple. There's another advocate to that, but I keep that out of the way. I don't like saying that last one. So, yeah.
Hey, Joe, do you want to explain what's going on? Sorry.
Okay, so with the picture that you're seeing here, my coil was getting breakout when I was putting I don't know, I'd like to say 7 volts, but I'm not exactly sure because there was some tests around that time, so it might have been 12. But I was getting breakout on the bottom of the coil, and so I figured I'd put it in resin. So I put it in resin. I didn't vac pack it, but I did the resin in such a way that I put it on a shaker, and it shaked all the bubbles out of it. It was like completely clean. I showed it to Jeremiah Pop, and he even commented, thinking he said that it was amazingly clear for, you know, my first time at doing epoxy. So I left it at that, and I started experimenting with the coil and doing videos. And just last week, when I was on live with Nathan and Ben, I looked at it at the light, and it was like I seen 1,000 points of light coming through it that were not there before. And it kind of blew my mind. So the next day I pulled up my have a digital microscope. It's 1,000 times magnification. And I looked at the epoxy where those points of light were, and this is what I saw. Multiple perfect bubbles. Now, at first I thought it was just bubbles in the epoxy. But once you look at where those bubbles are and where they're coming from, it almost looks like they're coming out of the copper. And that the epoxy is holding them in stasis because they're slowly coming out through the energy push. I could be wrong. It's a theory at this point, but I'm going to keep running the experiments, and I'm going to do the next one to Nathan's suggestion is put the microscope on while I'm running the coil to see if there's any change. So what you're seeing here could be EVOs, or it could be just bubbles inside the epoxy. But the experience states that they're not just epoxy bubbles. That's where it's at. But I've never seen a perfect epoxy bubble such as some of the ones that are on this video. And if you look to see, go ahead.
Somebody else pointed out that they're all on the wires. And no, if it's air bubbles in epoxy, they would be randomly wherever they were or rose to. They shouldn't be on the wires only, right?
Yeah, and if you look at some of them, it almost looks like they're pushing outside of the wires, like they're coming out of the wires themselves. So interesting nonetheless. It's going to require testing. And if the bubbles don't come out of the epoxy themselves, I might consider cutting this in half and sending half of it to Bob Grenier for SEM testing. But we'll see. Yeah. So that was the latest video. They could be EVOs that are held in stasis in the epoxy, or they could be air bubbles, but I'm leaning towards them not being air bubbles. But again, that would require some testing.
Well, I hope you do your presentation on Friday, this Friday. I hope
you do. I hope I'm ready for it.
You better be ready, Gerald. You had 2.5 months now, buddy.
Well, you know what, though? I had a breakthrough right after APEC because I was so I've been waiting for this, and then this stuff occurred. So I went and did some experiments, and I had another breakthrough, and I had to add it to the paper. So I got to go over it, and hopefully I've got it right. I'm shooting for this Friday.
Yeah, everybody wants to see it, man. Everybody's on there. We're all looking for this thing, man. It's just going to change everything. It's a total game changer what's going to happen here. So don't keep us waiting anymore. Find a way. Call in sick. Do what you got to do.
It's not my fault. It's not my fault that it didn't come out the way it was supposed to. It should have been on APEC. It should have had a whole bunch of people looking at it other than just us. And you know what? Piss on it. I feel honored that you are allowing me to do it on your channel. So, they lost out. That's the way I see it, I'm going to share it with the world. That's it.
Well, if we do it here, man, you got the whole thing to yourself, and we'll just pop in and watch and kind of comment a little bit. You know what I mean?
I hear you.
You know what I mean? So it's all yours, man, because we've been waiting. I'm sure you'll get a billion questions. I'll do my best to stay out of it and simply just ask the question when needed.
Well, you could be the narrator and ask the questions that are in the comment section. So there you go. That's awesome. Yeah, and I'm going to try and replicate one of my craziest experiments. I won't fully give it up until the day of the presentation because I don't know if it's going to work again. But I want to redo it, and if it works behind the scenes, I'll do it on camera so you get to see some craziness.
Nice.
Yeah.
Yeah, we've all been looking forward to it.
Friday sounds good.
Yeah, I ran a video today of your stuff, Gerald, by the way. So everybody, I ran a video this morning of all your stuff. You know what I mean?
Yeah, I caught a clip of that. I hadn't had a chance to watch it because I've kind of seen it before, but your comments always keep me thinking. I like that, right? So I always end up watching what you put out. Yeah.
Well, I just want to make sure everybody's aware of it, man. We're building up again to this whole presentation. Don't let my bubble pop again. Okay?
No, we're doing it. We're doing it, and that's it. You know, and
Nice.
Either people like it or they don't. Take it for what it is. Take it and off. I don't care. I'm just out there to show what I believe is truth, and I hope. And I said this to Nathan, Ian. You look like somebody who has to be on the list. So I have 43 coils made now, not 39 anymore. And they're going out to a group of selected individuals that want to test this tech, pull it apart, debunk it. In fact, that's what I told Nathan. I want you to debunk it. I want you to prove me wrong, because if you can't, that means I'm right. And if you can, maybe I'm missing something. Maybe I'm looking in the wrong direction. I want that information. So my intention is to send out as many as I can make. And they're coming with a book. And the book shows you how I got there, the dream, the platonic solids it's based on, all the 7 instabilities that allows energy to flow through the system, like diclotron instability, the skin effect, parasitic capacitance, kinetic inductance, the Miller effect. There's the proximity effect. It all comes into play. It's not one thing. It's all these things, or it wouldn't work. The system's dynamic. So when the time comes, I'd love to send you one. Doesn't matter where you are, Europe,
fantastic,
wherever, I don't care. I'll send it to you and pull it apart. Oh, and I am sending as well number sequencing for you to build your own. So from that point on, once you get the coil in the book, you'll be able to build your own. You'll be able to look at the experiments that I've done and replicate them, or not, whatever you decide. And you'll be able to take the number sequencing and start building your own geometrical forms of coils. And I think I included about 18 different types in the book itself, and then just going to let everybody take it from there. Sure, I built all the other ones, but big deal. I'd like other people to build them without me influencing it and see where people get, because who knows what's going to come out of it, right? So that being said, on the list.
I love that. Fantastic.
You're on the list.
Yeah, thanks.
Sure. And I appreciate everything you've done, Nathan, putting me on and, showing my stuff. I appreciate that. You're muted.
You're muted, Nathan.
Yeah, I got out of the conversation because I wanted you guys to talk. Because I had talked with Ian before, but you didn't get to talk to him yet. And everything you guys are doing is kind of like, you know what I mean? Going back and forth with each other. It's just amazing.
Are you in, if you don't mind me asking, Ian, are you in Britain or Australia, or where are you?
Oh, no. I'm in Florida.
Oh, you're in Florida. Even better. That's even better. It's easier to send you stuff. There you go. You have an accent. Absolutely. That's why I asked, right?
Sure.
I'll
cover the cost of postage. I'm easy.
Oh yeah, I'm not even worried about that. I'm not worried about. To me, it's like everything that I've done, I've paid for, or I've gotten out of recycled parts or the garbage and turned it into what it is. So as far as I'm concerned, if I have to put up the cost for shipping to every individual, I don't care. It's not about that for me. I don't care about the money. I don't care about the fame. I want to get this tech out. So to me, it's just part and parcel of it, right? But I appreciate it.
Absolutely.
There you go, Ian. No, this is his little thing of coils.
I saw this. Was it yesterday you put this out? I think.
Yeah, I put it out yesterday.
I saw this. Yeah. Those two in the top left, those did not work, right?
No, not at all. They were actually mimicked after a brain sequence that I was studying, because I was studying the brain for a while. And no, they didn't work. But I put them out just to show, not everything that we do works, but who cares? It still brings you to an understanding that you can jump off of, right?
Yeah, absolutely.
It's all about learning.
All right, Ian, I'm going to open this up to everybody. Is there anything you wanted to say real quick before I let everybody else in?
No, I'm good. Thanks. Appreciate the chance to have a chat.
And I appreciate you following my work, and I appreciate you being willing to debunk me later. So thank you.
Mike, what happened? They're like half there.
You look like you're in a portrait, Mike.
Your mic's not on, Mike. Hey, look at he's smiling with black teeth.
Yeah. Looks like he's on Pirates of the Caribbean. There you go. I can hear you now, Mike.
I'm I'm in Deep Space Nine. Deep Space Nine, man.
Yeah, almost.
That's so great. It looks so funny, dude. I'm sorry. Awesome.
Totally yeah, you should have faded into the camera slowly, right? Done it all Darth Vader like. That would have been cool.
Oh my god, that's so great.
Nice.
I got a green screen, things you can do with a green blanket.
I hear you. I got one of these white for the projector that's above my head. I'm trying to get it set up for when we do live. It's going to post stuff behind me. We'll see how well it picks up on the camera, though.
You guys do it on the projector, not like pull it off on the screen? And
yeah, well, no, I got like different types of media, and I got a digital projector that's bolted to the ceiling above my head. I just have to adjust it right, and then it'll show up here while I'm talking to you. But I mean, that's not my only way of doing my presentation. That's just an added bonus.
Oh, right on.
Like this whiteboard, right? It's old school, but it's an added piece of media that you can use to show what you're doing.
So you're going to do an experiment on that day, or are you going to show like a live experiment as well?
That's the intention. And it's going to be something that isn't on my channel. It's going to be something you guys haven't seen before. If I can replicate it, it's in my book. I've done it before. But again, we'll see. I'm not going to even bullshit myself here, right? This one's a little bit crazy. So that's why I said we'll see some craziness if I can get it to work.
Cool. Sean wants to know what's in, what's out.
Depends on what it is that I'm doing with the coil, but my watts in on lighting that one cube in the one video we shown was 1.8 watts, and watts out. You know what? I didn't hook it up to a meter at that point, but the light itself almost blinded me. So it was at max, and it takes 94 volts, 1 amp just to light one panel, and there's 4 panels on that cube. So I will do the watts in, watts out and put it on video in the future. I just have to get a second meter.
I remember the Whoppers. Too bright. Yeah. Got to have some Whopper box in the middle.
Yeah, I had to go Whopper time on that one.
What I see with these coils potentially doing is reusing the flyback right away.
Mm-hmm. Yeah,
based on the way they're wrapped so close together, in a way that the flyback doesn't get a chance to. Well, I mean, it can radiate onto the other coil as well. Any other coils close to it. So when you have so many coils that are not doing anything, but one of them is being energized, and the rest are just sitting there doing nothing, they're basically stator coils.
Kind of.
and that way you can use them in the way they're wrapped around your primary. If the primary is the one you're pulsing, I don't know if that's what you're calling it, right?
Yeah.
It is, okay. So yeah, the primary coil, if is being pulsed, you could, these coils wrapped around there are statoring that primary coil, and we don't really do it like that. Nobody's ever really done it like that. It's just a transformer, primary, secondary, one coil and another coil, but not a third and a fourth and a fifth coil, which is just a third and a fourth and a fifth layer of picking up EMF fields that would otherwise be wasted.
There's 12, and when I put the whole system together, there's 15. And they all pick up individual.
You got forward EMF, and you got backward EMF.
Yep.
On the flyback side.
And I pick up on 12 on the outside, and I can pick up 3-phase on the inside of the core. While I do think the
flyback side is a little bit weaker.
Good eye. It is not by much though. It's about.
But I have a theory how to overcome that. If you want to hear it.
What's that?
I have a theory how to overcome that if you want to hear it.
Sure, go for it. I'm always open-eared.
Okay, first of all, you got to get your forward signal in phase with the flyback signal. And
I can't because the system.
One of two ways you could do this.
Okay.
Hold up, hear me out.
Okay, sorry.
You can delay. You can't really delay the flyback signal. So that knocks out one of the two ways. I thought you could. You could delay the flyback signal with a capacitor, recreate the same signal by delaying it, but you can't recreate a flyback signal with a capacitor. So you have to speed up the flyback signal. You have to speed up your forward pulse to catch up to the reverse speed. Mm-hmm. So if you're going on, and I didn't say off here, I just said on. If you're going on at a certain rate, remember the rate at which the flyback goes in reverse is quicker than the rate at which you go on. So if you can speed up your frequency of your on frequency fast enough, you catch up to the rate of return of the flyback's speed of frequency, which is at an unknown frequency. It's not at your frequency, whatever frequency you're pulsing on and off at. It's not at that frequency. I'm talking about the frequency of which it returns. The speed of which it returns is a frequency in its own regard.
I get exactly what you're saying.
It's at light speed, technically speaking. It's light speed.
I will try your experiment.
How do you catch up to that frequency? So that's the theory. If you do catch up to light speed, yes, you can put your forward pulse in phase with the reverse flyback and create a amplification.
Yep.
Done. Because you're in phase and the two signals are in phase. And if your primary signal is at the speed of the reverse signal, which is hard to achieve considering it's light speed.
Mm-hmm.
What I'm saying is the rate of which you go on and on is at that speed, light speed.
Yep.
Then you are at the rate of the return path of the flyback. You're at the same speed, which is in phase.
Well,
and so your signals will overlap. The two flyback signals will line up. And if your primary signal has a gain of one or more, doesn't matter what the secondary signal is, you're going to have amplification.
So
as long as they're in phase,
you're going to pull out the Hutchinson effect if you start crossing the beams here, okay? You know what I mean? You're not, unless you want to fry something, I wouldn't try it because you need a north and a south. It's an experiment
that's probably not even possible.
Yeah, listen, you need flow. If you take off the flow and keep it concentrated, get ready to blow up whatever's in the center.
It heats up the coil itself, and then it'll blow the transistor. I understand what he's saying, though. There's
transistors that can switch at light speed. It's not going to happen.
So there's
not going to be in phase. You're not going to be in phase with your primary signal on or the reverse signal resulting from your primary signal is what I meant to say.
There's another way of pulsing it that could allow Mike's experiment to work. And you know what? I'll get into that. Maybe not right now because it's going to take a little while to explain. But there is a way. Remember, there's 4 lines on this coil, right? There's a positive and negative on the primary and a positive and negative on the secondary. But you don't have to pulse from your primary's input or your secondary's input. What if you pulsed the primary's output and the primary's or the secondary's output? This system, because the way it's geometrically formed, does totally different things depending on how you pulse it. So I understand what you're saying, Mike. Let me give you something to think about. What if there was a way of pulsing the primary and allowing the secondary to pause the energy that it's collecting and releasing it just before the pulse of that primary
To put them in phase.
they come in balance to perfection? Let's just say this system can do that. But it matters on how you pulse it and what you're putting on your secondary to allow that energy to flow so that it can do that. Does that make sense?
So are you winding it like a bifilar coil then? Positive and the negative, or you know what I'm saying? And
Yeah,
it automatically pulses back?
Yep. It acts as a wave. So when you pulse the primary, right, through induction, the secondary picks it up. But when that power is released in that secondary through either the capacitor or the diode or even pulsing itself, it takes that wave that it accepted and spits it out the exact same way, 180 degrees out of phase, at such an extreme rate, it's almost as if there's no delay whatsoever.
Right. According to the Nunez method, it doesn't matter where you start as long as you create that toroidal field, the counter rotation, and that's what matters.
So isn't the flyback 180 degrees out of phase with the forward voltage?
Yep, it's wired that way.
I mean, that's just the natural effect of it.
Yep. The minute I tap the coil once, it's 180 degrees out of phase.
No, I'm saying, isn't the flyback 180 degrees out of phase with the forward?
With the primary, yeah.
No, the forward voltage, your plus to minus signal.
Yeah.
Then you turn that off, and now it reverses polarity and goes the other way. Isn't that reverse polarity flyback 180 degrees out of phase with your forward?
Yes, it is. Yes, it is. But remember, my flyback doesn't come off the primary. It doesn't feed back in the primary. It literally is captured by the secondary. So
right.
do
you attribute that to the bifilar winding?
Yes. But
do you attribute that to being 180 degrees wound, 180 degrees out of phase?
It's bifilar 180 degrees out of phase wound that makes the system work. Well,
it's being a bifilar and being 180 degrees wound, 180 degrees out of phase with the primary wind also helps the 180 degrees flyback signal to better be received.
Yep, I capture it almost immediately. I would say instantaneously, but my eyes can't pick up on that. No human eye can.
That makes sense why I get self-oscillation effects sometimes on these Bedini SG systems. They're bifilars, you know?
Oh, yeah. Bedini, he knew what he was doing. Like the tape deck video.
At first I thought it was a battery.
Did you watch it?
Oh, did I ever? Not only that, I was looking at the circuits and I was looking at what he did. I think I figured out how to run a scooter motor all on its own.
Oh, that'd be cool.
Not sure yet. Big boast. But what Bedini did, man, with the SSG, guy was a genius. And all you have to do is apply it to the windings of a scooter motor. And on your resistor for your Joule Thief circuit, you use a throttle. But you have to have your resistance matched to the right system. So
I I see a lot of these circuits, even the ZVS. It looks like they're using the flyback to trigger the ZVS, and it even looks like that with the Bedini circuit. Like it's in a lot of these oscillators and the Joule Thief, they're all using the flyback to sustain the triggering. You know?
And I could.
It seems to be looking like that the way it's wired, you know. And stuff.
But that's not my goal, though. Right? Could I run it into a loop? Sure, I could. And then I get kicked off YouTube. They won't allow it. Any video that you close loop your system on, you're getting taken off. So
really, I thought
you've never seen me do it, and I don't think I ever will, not unless I'm ready to go bye YouTube. Because I mean, I don't know, right? I don't want.
I was considering just running a live stream with some of my pre-recorded videos, you know, just on a server, because I see a couple of other main like channels do that. Like I think the Young Turks just has one just streaming 24/7. So if they can do it, you know, like I don't know, like maybe I can set up a server somehow and just run one, so I can have a continuous stream like 24/7.
Maybe, and then just let everything out on that. Never let it shut off, so they can't algorithm it.
Your ISP is gonna knock on.
Yeah, because it's when it closes down is when you get flagged, isn't it?
Yeah. Just leave it running.
No, your ISP is gonna call you. Hey man, we need you're hogging all the bandwidth.
Give me 1 second, okay? 1 second. Listen, I'm gonna post in the. I'm gonna post.
Get the.
I'm gonna post in the chat right now, okay? Where you can find the link to the tape motor. You're also gonna find, what was the other one I showed you, Gerald? The one from Germany.
It's on the tip of my tongue. I just can't remember it at the moment.
Anyway, I'm gonna leave
Howard Johnson. Howard.
No, it's not that one.
Okay.
It just has one name. Just one word. Anyway, I'm gonna link it in the description for you guys. Enjoy it. Go on there. There's 26 videos on there for Bedini. It's also a research place, so you can go on there and find stuff on Hutchison and some other people. You can also pull up articles and stuff. So here it is, guys. I'll send it.
Great. Thanks.
Yeah, I tried to find my email link because I signed up for Hutchison's his membership package, you know, the $34.99 or whatever, to get access to all of his videos and information on there. And mysteriously, the email, like not the receipt email, but the email with the link in it is not in my inbox anymore. So I looked all through that son of a bee, and I don't know what's going on, because I know I looked on stream for at least 2 or 3 hours looking for that thing in the inbox, and it was not there.
Did you look in your trash folder?
No, that's actually something let me look in the trash folder right now.
Just in case it got put in there on accident, you know what I mean? Just find out.
No, that's a good idea, because you know, I don't want to jump to conclusions, you know, like I don't want to say like, oh, somebody like did this maliciously, but I did have a link in there with access to his membership, and I wanted to live stream some of it, but I'll check the trash right now.
You do know that you're on live with one of the most like shadow banned people on the internet, right? Just making you aware.
Yeah. I mean, you've seen some of the content I put out, and what, I'm not even at 1,000 yet. Like it seems like my channel's like plateaued.
You know what? Your channel grew faster than mine. Yesterday, the day before, I was at 705, and that's taken me a year and a half to build. And I've been on lives endlessly, and you know, in the background of APEC, and dealing with like Jeremiah Pop and Jeremy Reese and Alien Science, all that, right? And yeah.
And something that really helps is reminding everybody to let's subscribe to Gerald's channel right now. Everybody watching, we got 36 people watching. Anybody that's not subscribed to Gerald's channel, he's got a really great set of videos that I really enjoy. Yeah.
What were you saying, Mike?
People want to see them circuits, man. I mean, most of your viewers are going to be, you know, technically savvy, and those are the guys that are going to want to see the circuits, guys and girls, whatever.
I'll do a schematic for what I got.
Look through the
I mean, I know you don't want to know.
you don't want to get your spikes, you know.
No, it's not that I don't want to, Mike. I have no problem drawing a schematic. It's just, how do I put this? I suck at it.
Maybe just one for not to be accurate or nothing, but just like to give a basic understanding of what's the fundamental principle of what you're doing, you know?
Okay, I can do that.
People also like to see you in front of camera, you know, like maybe with a diagram pointing,
don't have to be, you know,
describing the science
and all that, but just maybe enough details to see what the concept is, you know? I mean, that's how I make my stuff. There's not a lot of details in my stuff, but it shows the basic concept, you know?
I get that.
It's a Lockridge device.
Well, let me just
video demonstrations are great, but you can't tell how everything's connected like that, you know?
Hold on real quick. Lockridge device, they pulled out in Germany after World War II. It was an over unity device they used to light up all the tunnels under the ground in Germany. So they brought it back to the U.S., and the guy that was researching it wasn't able to put it back together, so he gave it to Bedini, or his family did, and I can't say what happened to him. Anyway, it just didn't work out, and Bedini said he would never release it until he got it working, so it never came out anywhere. He just shows you a walkthrough of what was in it.
What is it called? Do you know?
The Lockridge device.
You got it in chat right there. Lockridge device. Interesting.
I believe that was the one that was 400 watts all day long, right? Like it wasn't a lot of power, but it was enough power that if you had 2 or 3 of them, you'd be running your house or something to that effect.
And what was it? No input power or low input power?
I think it was very low, if not none at all. Yeah.
I mean, if I had a diagram of your stuff, I would have built it already.
It was over Unity. It looped. So as soon as they got it running, it stayed going. And they actually had a version of it that went in campers inside the U.S. And they would only sell it to people who had campers. So, but they would go to replace the brushes, and they replace them with the wrong ones, and it would ruin it. It would never run again.
Yeah, anything that's over 200 or 200% over Unity is going to be able to run itself indefinitely, you know, as long as the parts hold up.
Well, the alternator generators that I built, I get 400 watts out of each alternator without any input whatsoever.
Gerald, you should have one of your coils that you know gets 200% or more efficiency, and just see if you can just run it. You know, like a time lapse.
What do you mean? Like just to run it continuously?
Yeah.
I know what it'll do. It's one of the reasons why I don't do it.
Will it build up? Will it just build up and then just because you don't have any load on it or enough load? Yeah. No, it'd be cool though if you could just show it just running indefinitely. But yeah, like you said.
You know what?
Internet Archive, just so you guys know, it links right to this. You see them all down in here, all the links. You can download them on the bottom right-hand side. You'll be able to get to them, link it, pull it down, do what you guys want, watch them, load them up, keep them on your own server, have fun with it.
Oh, nice. Awesome. Thank you. Thank you, Nathan.
You guys want to see a Bedini mod pulse motor?
A which?
Do you guys want to see a Bedini modification pulse motor? It's like
sure.
It's based off the Bedini SG setup, but it's like a modified version.
Sure. I'll show my circuit later on. It's a modified jewel thief. It's really, there's not much difference other than a small capacitor bank at the right spot and then where the ground goes, which is actually one of the key factors to raising it a second level. But we'll get into that.
It's a magnetic relay, and it's moved up and down with 2 little electromagnets. So there's a magnet. You move a magnet with 2 bars attached to the magnet, and you move that magnet with 2 electromagnets, and you'll see that. And then it triggers 2 power sources to 2 coils in sequence, sequentially.
Nice.
I call it a double source, double pole throw relay, which I don't think they make that. You have to make a commutator to do such a function.
Are you thinking about actually building it?
Oh, I kind of already did in the schematic here. It's definitely going to work based on the schematic. And
no, I'm just excited to see.
I'm going to build it. Yeah, I'm going to build this relay. I have to, because I don't want to use a commutator. Oh, I'm going to get the printer, the 3D printer. Nathan.
Oh, okay. Yeah.
It's
going to take me a couple months to get phase 2. And
I'm going to have to learn the damn software now, which is what I don't want to waste time doing. But
dude, it's easier than you think. It'll be like 2 seconds to learn.
I hope so.
Yeah, 3D printer will make everything easier. I'm planning on getting one at some point.
Creality.
I got 6 sitting right beside me. I got another 4 over here. Trust me, I just sold like 5 or 6 of them, so I can do more experiments. So, it's
why did you need so many? You kept upgrading or something?
They're for different things. One's for ABS only. It's enclosed. Another one was dual head, so it'd print one color then another color.
Wow.
I had 400 by 400 beds on them. There are 2 of those. And then I sold another one that was a faster version of that. And then these are just slower versions, but I put them on fast speed. So they absolutely keep moving. So like a 14-hour print, man, we're talking 8 hours. I can knock down things in half. Trust me, I change the nozzles on them and get them with bigger, thicker stuff so they fly out faster. I hate waiting. I want a prototype, get it done, work on it, you know what I mean? Blow it up, build another one. So it's got to go fast.
Yeah. Does the temperature of the material help if it's like not heating it up too much and not as viscous or too viscous?
Well, it depends what you're working with. Normally, you're just working with PLA. If I run ABS, I'll just take one of these areas over here that I have, and I'll just put the front on it, and it'll seal up the whole thing. So no air will get to it, because with ABS, just walking by it makes it lift. So it's a pain. You have to keep it enclosed.
The things that I could do with a printer. I have designs of things I haven't even shared.
I keep saying this: buy a CR10 used, get it for $80 to $100. Okay, it's not bad, and just get on the thing one-on-one with me, and I'll teach you how to build it, and we'll get it going fast. Because it's a 300 by 300 bed, but I can cut the time in half. And all the new printers, they can't go any faster than that CR10 can right now, unless you're talking about Bamboo Labs or, something like that. But,
really?
Well,
yeah.
When I'm in the market for a 3D
they got CR10s for under $100, huh?
Just go on OfferUp.
Okay.
OfferUp or something like that. That's where I go. Local people, they all just want to get rid of the stuff. I find them for $40 sometimes. And all they did is somebody ripped off the head and they didn't know how to put it back on. You know what I mean?
Yeah, I'm good with that stuff.
I'll just, don't feel wrong.
How much are there heads? You got to buy new heads or something? Or
they all have it there. They just have no clue about the 4 or 5 bolts that goes in it. That's it.
Makes sense.
I get people like that all the time. They burn a wire and they think they burned everything. And it's like, it's just a wire. You know what I mean?
I've got an OnQ amp that's 250 watts a side, and the person gave it to me, and I was like, I'll fix it and give it back to you. And they're like, nope, it's garbage. I don't want it. It pissed me off. I was having a party. I took it home. I changed the fuse. I have a brand new amp.
Oh, by the way, Ben, how did your amp come out? Did it live?
No, it's dead.
Oh man.
I haven't taken it apart yet, though. I mean, I could rejuvenate it. I could bring it back to life.
Did you open it up? Did you take the cover off and look inside there?
Not yet.
Oh
yet.
well, yeah. Come
Oh,
on,
then
now.
you don't give up yet, man. You didn't even open the box, man. Come on.
Hey, Ian, he was
Could be
running
just a
his.
fuse or
Hold
It
on,
flashed.
guys. Hold on.
It flashed like a resistor burned.
fuses do that.
I mean,
Fuses do
maybe
that
or
too.
fuse, yeah.
Hey, Ian,
So
no,
that's-
tell him what you did. Tell what you
Resistors
did with the
don't
little
flash.
ball and your thing.
I mean, sorry, transistors.
I was doing here. You want me to present
Fuses
so you
flash.
can visually see what's going on?
Or transformers.
yeah, if you have it real quick, that'd be cool.
It's your transformer
Yeah.
or the fuse.
Or he blew a cap.
You would smell that. It would smell weird. Or you hear a bang.
That's true. That's
Oh,
true.
dude, no.
Or you hear
he
or
blew probably a
you know,
resistor.
Yeah.
you'd hear air popping or like.
Yeah, resistors get red. They get pretty bright.
Yeah.
But the resistors smell like burning material. You smell it clearly. And
Wait,
the
said he saw a big flash.
transistors, you can't tell if a transistor is bad. without
He's seen the
putting
puff of smoke too. I remember when it happened.
Yeah, that could be the transformer. That sounds like the transformer.
Yeah, maybe.
It's a $5 transformer. You could probably replace it. You know, got to do.
Well, if you ever get up here, Ben, I got an extra amp for you.
Probably even rewind the burnt winding in the transformer if it's burnt.
So this is me pulsing at the Schumann resonance. 8 point. What was it? What's that? 8.
With all the complicated
or 7.83
physics,
7.8
involved in
7.83
these systems.
Yeah.
Yeah.
Here's the kicker: it wasn't that
So this is basically here. I'll show you the circuit.
use of a Ford diode and single capacitor. The Nunez called this design the PoE Vortex Coil. It stands for Peace on Earth, but I just call it the Nunez design to give them credit. After all, they were the ones who came up with this easily made sliding disc frame for our coils. They not only made it, they perfected it. And we need help trying to recreate their advanced version 3 432 vortex
So as you can
coil.
see,
Jordan from Alchemical Science might be
I'm
able
getting
to tackle this
over
one.
unity in
The
this.
frame needs to have a very thin V-shaped opening for a single wire set.
So this is the advanced version 432 coil that supposedly won't produce any ozone like some of the other coils that we see when pulsed at high
That was cool.
High frequency. Yeah.
right.
And you have that one now, Ben?
No,
Is that
this
your
is the
wind
one
then?
I'm trying to. This is the one I'm trying to get people together to try to recreate. So I don't have a 3D printer to actually recreate this, but it just needs to have the opening needs to be very thin, so one set of wires can set on top of each other very delicately and evenly, very thin V shape. And supposedly this is their most advanced design for over unity production and also healing. They claim at least.
Okay.
PEMF. I got papers on it. It's the real thing, man.
But yeah, this is the PoE vortex coil. As you can see, it's not perfectly symmetrical, but it still works. Yeah, I didn't think I'd be able to get it to work, honestly, but it works.
Nice.
Nice.
Mm-hmm.
Very good.
The geometry is the determining factor for the presence of a detectable magnetic field. The closer you get to this precise geometry, the more you are choosing the path of least
It's a
resistance for
nice
the energy.
even.
In a straight line
360
wire,
degree
you couldn't be further
turn
from this path, since nothing in the universe
in
travels
electrons.
in a straight line. Thus,
motion.
it is within the realms of conventional science to assume that geometry is an integral factor to maximizing the performance of any system. This is not just one system. It is an all-in-one system, a transformer, a resonant circuit, a Tesla coil, a strong electromagnet. It is the holy grail of physics, a system unaffected by the weight that it carries.
So this is the two circuits that I managed to grab from their website. As you can see on the left, there's the traditional closed circuit that produces a speaker, or it's good for a motor. propelling a rotary, I assume. And on the right, we have the open resonant circuit, where you basically have a crisscrossing of the input and output for the two channels.
Yep.
And this, supposedly maximizes the resonance, allows it to resonate more, or gives it more of a cavity to resonate. I'm not really sure the exact mechanism,
sorry, go ahead.
Go ahead, Gerald. No,
Well,
go ahead.
That's the same thing as a PMH. What it does is it basically crosses your field, so your voltage is going down one way, and then as you push voltage the other way, it's like creating current. Does that make sense? I'm not explaining that correctly, I believe. but the PMH itself is wound the same way. It's the end of one coil goes into the beginning of the other coil, and because of the way that it pulses and the fields run, it actually creates current.
Right. You see in the left here, they say no vibration. There's a vibration spin for the magnetic dipole or whatever, and then there's no vibration spin on the open circuit. So what I detected was no pole when you put like your physical magnet detector in there, the one that's on the hinge, just a magnet on a hinge. It's clearly got a electromagnetic field, but then you put your digital detector in there, it doesn't detect anything. Well, it's probably got something that's very, very sensitive, but it's condensing it, I think, down to nothing. And you can see in this video, where is it? The magnetic monopole test that I did.
When the field disappears, I call that the null zone. That's right in the center of my open core, like right in the very middle. There is no field. It just nothingness. And I think that's what the Rodin Coil does.
The Rodin Coil is also bifilar, right?
Up the gain a little bit. Yes, the coil is bifilar. So just real quick, because I don't think Ian is aware of how many wires I have in there. There's 24 wires in there, and they're separated into two channels. So they're all in one bundle, twisted bifilar, but they're separated into two channels, basically. So they're sitting on top of each other, but not directly connected. And the other channels are connected in series.
Okay.
As you can see. And that's not sawtooth, that's square. I was reading the app wrong.
So one channel is one wrap,
generated,
and the rest of them are all in series.
You said what? What, Mike?
So one channel is in one wrap, and that's the one you're giving it the energy, and the rest of them are in series, taking the feedback.
So the two channels that are not connected are both in series. So you got 12 wires in series producing channel A. That's the input. And then you have 12 wires in series that are not connected to the other 12, producing the second channel. That's the output. That's basically
your secondary.
Yeah, it's some kind of inductance that's happening because the two channels are not directly connected, but they're twisted together in this bundle very tightly.
Are the second
I think I over tightened it.
Are the second 12 wrapped together?
Yes, they're all wrapped together, all 24.
I mean, what I'm asking is, do you have two pairs of 12 wires? One set of 12 wires wrapped together with another set of 12 wires wrapped together, and those two pairs wrapped together to make your bifilar? Is that what's going on?
Yes, exactly. And then you just separate the leads into two channels, right?
And you're left with 4 wires in the end.
Yes, you're left with 4, 2 input, 2 output, or however you want to hook up your circuit. That's how I did it, replicating the PoE vortex coil. There's other methods where you can use more than 2 channels. I'm going to experiment with 3 channels in the future and see how that works. But you can see like there's a strong electromagnetic field generated at the low end of the frequency range. Put our magnetic pole detector in there. And you put the regular pole detector in there, the regular one on the hinge, and detects, but you put the magnetic one, which, you know, works and detects, you know, I show you it actually working with a little magnet, a neodymium magnet, and it doesn't detect anything. And it's very wild. And then depending on the frequency, I determine, and the power level, you can actually detect a North Pole, and I've detected a South Pole as well.
So you're using the second pair, just to power things. And
yes, I'm using channel A to power.
To power the device, and the channel B is just to power devices.
Right, the load.
It's clearly got an electromagnetic field. But we are not picking up
so Ben, are you you've wired this, it's like one long wire, right? To make up both directions of the coil winding. So you'll go one direction first, and then you'll reverse it and then go the other direction. So all 24 wires are like Litz wire. They're all wound together in one bundle.
Yes.
And then you separate them out into two channels. And then you'll connect, you'll take two channels, and then you'll connect all the wires for the other strands in series. Is that right?
Yes.
How is Litz wire?
And then
exactly...
you'll see.
Are you doing it from the channel A into channel B, or you're separating them out into two different coils essentially, although they're intertwined?
Well, it's both. So you are
the other
separating
wires
it. Yeah, you are separating it into. They're basically two coils in here, and it's wrapped into one.
Yeah.
So you have one binding of wires, one bundle of wires that's separated into two coils, basically. And then depending on your setup, yeah, you can have channel A be the input and channel B be the output. But in the Nunez method, you have it crisscrossed, where the output of channel A is actually the input of the load. And it's, you know, it's a different way of setting it up. But depending on the setup.
Do you need a diode to make, were they using a diode for that?
I believe so.
Yeah, you would have to. You would have to be able to do that. Yeah, you can diode it back to the...
I'm not sure. Like, I can actually, let's look at the circuit real quick, as I have it up here. Where is it?
Was it the open circuit or the closed circuit?
So no, actually, this isn't actually the good design. I have a fuller diagram I can bring up. Give me 1 second. It's in my do-it-yourself guide.
Well, it's AC, so probably don't need a diode. Because AC has a positive and a negative. It's got no polarity.
Okay, I'm going to present this. Stop screen. And then we're going to present this do-it-yourself guide that I put together. And this has a couple of better...
Groovy background. What's that? Is that the... is that background like a portal or something? That gold.
You said what, Mike?
The background you got there. Behind the page.
Okay. So this is it. This is the proper diagram that was very hard to find. Here you see that I think all they use is a capacitor. And they recommended a high
Okay,
high
a capacitor will not pass AC. It will convert AC to DC. An inductor will pass AC and not convert to DC. Just thought I'd throw that in there. So that capacitor will take the AC signal. If it's not, I can tell you right now, that capacitor is not a polarized electrolytic capacitor. It's an AC capacitor. I'm positive.
Well, in the description, they recommended a 200 or 2000 volt HV capacitor.
Yeah, that's definitely not electrolytic. They don't make them that high voltage electrolytic, that high voltage. That's AC capacitor. So that means that capacitor could take the flipping polarity of the AC signal and convert it to DC for that
For
light.
the load?
Guess. Yeah, for the light. Yeah.
Yeah. Huh. Yeah, because that's what would power the light more efficiently, right? The DC power.
I think the capacitor would take half the AC signal and pulse it and make it a DC like that, making that light get its frequency through the halfway pulse.
But yeah, here you see the only thing that they're using
is a second capacitor. I don't know if it's put in parallel there, or in series, but a second capacitor might rectify the whole AC wave into a solid DC line. And that light would not.
So the output of channel A is connected to the positive of the load, and the input of channel B is connected to the output of the load, and the output of channel B is connected to the amplifier, which is very unusual way of hooking up the circuit here.
Well, it's just putting the signal into the coil from the other direction, right?
Yeah, and that's the idea, is reversing it. And
right, so
you want to have the energy going one way and the energy going another way.
The AC capacitor does that because it's AC. It could go both directions. So you could polarize AC one direction on one cycle of the wave, and then when that cycle of the wave is going the other direction from your source, the AC capacitor will then dump the other half of the way the other way, kind of thing. I don't know how to explain it, but yeah, AC capacitors, 15.15 microfarads. So that's a high frequency right there, low capacitance. And I see it says, wait, don't move. I was looking at that. Generator frequency generator ideas, Android. Okay, 12 hertz to 80 frequency generator. You got two generators here. Why? Oh, one's the closed circuit. Okay, you're talking about the one on the right now, right? Okay.
Right, and then
so that's
again,
the stereo amp, plus and minus. Your output is the load. The other two wires. You have 4 wires on this whole thing. The 2 are the in, and the other 2 are the out. That's the 4 wires on your coil.
Real quick for Ian, if anybody or Ian or anybody wants to try to replicate these experiments that I did, that are just basically replications of the Nunez experiments, the required increments for tuning your coil would be a resolution of 1 hertz. So
you see
what I found was actually tuning it around, like using 100 hertz increments was more efficient, because it took, it takes forever to try to find that sweet spot, but it was a little bit easier using 100 hertz increments for me.
So Ben, you see
were you using a scope to find it?
No, I didn't use an oscilloscope at all. I just used multimeters to try to look for the spike in output power, because that's basically what the Nunez descriptions call for. Look for a spike in output power, and that's what I did. Basically, just followed their instructions to a T, and it worked. You find that sweet spot, and it's an initial sweet spot. And like you said, I think as you'll see in the guide here, there is a theory of mine that aligns with yours in the phi ratio and the harmonics of it. You'll find the initial resonant frequency, and then it seems to be in using the phi ratio as an octave of that initial, you'll find the next sweet spot, and then the third harmonic, or the second harmonic, or whatever, the third sweet spot, that is supposedly the range for the Nunez method, which basically supposedly times the output by 10. And I did actually witness that in very, very small increments in the microvolts or millivolts. I forget what the increment smaller than volts is, but it did times the output by 10 at a very low range. It was like 12 on the input and then 120 on the output, which is very, very cool. But so it does work.
Right. And it's all usable energy, right?
Yes, yes. You know, that's why I hooked
Right.
up the circuits. And I do have if you look at some of the live streams that I have a reference circuit up there as well to show you, okay, so the stereo amp receiver is outputting the same amount of power for both, because it's a surround sound system, you can use multiple channels. So it's outputting the same amount of power to each channel. You can use one channel for the coil, and what I did was use the rear speaker channel for the reference circuit. So you can actually see visually how much power is supposed to be going into the system and how much power is actually coming out of the system. And the fan spins faster. The lights are brighter when it's in that resonance range, and it lines with the multimeter. But outside of that range, it's, lower on the output, which is very incredible. Like when you think about it, that's pretty cool.
Yeah, it is. I mean, so you're obviously using a power amplifier and using your phone for the signal generator, but
yeah, phone or
and then
laptop,
passing
whatever.
Right. Okay. All right, interesting. So, and then but the amplification is probably is that attributable to the actual power amplifier you're using to put the input signal in?
Yes. So
So
you can
you're
actually,
measuring it going in and coming out, right?
right, and the amp actually is kind of like a poor man's makeshift power supply, because you can control the power coming in with the gain, so the volume knob essentially, and you can kind of control it that way. And if you have a multimeter hooked up to the output circuit, the reference circuit, you can see exactly how much power is supposed to be coming out of the system, and it does kind of align with the number. I think it's like 5 is around 5 volts supposed to be coming out of the system or something like that, 5 on the knob.
All right. Yeah, it's interesting. Yeah, I'll definitely give that a look.
Yeah, it's a very easy. Yeah, it's very that was the idea, that they wanted to put out a very easy, replicatable, and low cost system that you can try yourself. And just to be aware, people, this does supposedly, the Nunes method put out high voltage, so be careful and be aware. Like know what you're doing, and be safe.
Yeah, but if it's a power amplifier, though, the signal coming out of it is polarized, right?
Yes. So you have a
Okay,
you
so
have a
it's not AC then, right? Am I right to say that? In which case,
so
that
it's
capacitor down at the bottom is probably like a smoothing capacitor or something
yes,
to
that's the idea,
rectify
is
the
the
circuit to
capacitor is
start
supposed to
with,
smooth
right?
out the signal. Yeah, the capacitor is supposed to smooth out the signal, but the
Right.
signal itself coming out of the amp, it's DC until you put the tone into it, and then it modifies the signal to be AC. And
Okay.
right, but the capacitor does smooth out the signal because, again, you're probably getting some kind of filtering from depending on the amp that you're using, so and all sorts of different noise that you have to filter out for the signal. But yeah, that's the idea, is to smooth out the signal with the capacitor. And they do recommend a 2000 HV capacitor.
Yeah.
Hey, real quick, Ben. Sean wanted to know where he gets a copy of this.
Oh, it's in my do-it-yourself guide, so you can get that on my channel. Here, I'll post a link in the chat here.
So what do you think, Ian? We got a whole bunch of stuff going on between everybody, huh?
Yeah. It is. It's great to see. It's just a matter of wow, just getting the time to get everything done. It's crazy, but it's great. I mean,
it's a remarkable time for sure. But yeah, the timing is an issue for me as well.
Yeah.
Well, what I like is people are kind of doing some of the same experiments, but there's just enough difference where you can cross-reference. You know what I mean? Between the different ones, and then try something different once in a while.
Absolutely. Okay. All right, just getting your.
Oh man.
Right. Got
For
it.
my okay, I drew a small diagram here. I don't know if you can pick that up on camera.
Oh, here, let me stop screen. There we go.
Let me go to present.
So
Go ahead.
this here is a 2N3055. And then you got your neon that goes from your base to your emitter. And then your signal generator. Positive goes to the base. Your negative goes to the emitter. Your power supply. Positive is to the collector. And your negative goes to the coil. Then and it goes to the primary, the input on the primary. Then the output on the primary goes to your negative. So not only am I running this negatively biased, when I turn the pulse on, it fills the coil. And when I shut it off, that's when it releases. So that's the circuit. And this part here is where John Bedini would run his charge battery from. So it's a diode to a capacitor. And then from the capacitor, I usually run it to a capacitor bank or a secondary battery. I'm sorry if you guys are picking up the background here.
It's okay. I'm just happy to see this. Can you hear us?
Sorry about that. Go ahead.
Can you hear us?
Yeah.
Yeah, I'm just happy to see this. So, okay, what's the neon light? Is that just a draw? It's just it's like pulling a little energy out. Is it like a cold energy pull?
Okay, so the neon is to stop the 2N3055 from blowing when there's too much current in the system. But that doesn't light up unless I'm in resonance. And that current, I believe, is scalar. Now, John Bedini references when this light is on that it's a scalar pulse or a negative pulse or etheric or quantum vacuum, call it what you will. But when this turns on is when his system is getting that excess pulse factor. Now,
so it serves two purposes. It's an overflow and it's an indicator.
Absolutely. And I'm going to tell you a little something I do with my circuits that I keep out of the videos for the most part. So here's a little tidbit that you guys should try and use as much as possible. If you wire your circuit like this.
Nope, cutting out a little bit.
Okay, so can you hear me now?
I can hear you.
Okay, so when you wire your circuit this way and you come from a diode off your collector to this capacitor, instead of going to a secondary battery for charging, go to a capacitor bank. And then that capacitor bank acts as an overflow for your circuit and your coil in its entirety. So when the circuit's being pulsed, because the way this circuit is set up, the coil fills this capacitor bank like that. 200 volts. You can make a larger. I have a 250 volt capacitor bank and it charges it in the blink of an eye. And then this goes into resonance and starts igniting. The neon goes off and my coil goes insane. So if you use this here as a capacitor bank as sort of like a backup power supply for your whole system, it actually feeds back into the coil and you can replenish it faster than you even notice it's going into your coil. It's just the way that the circuits run. And this little end part here with the capacitor bank, I'll show you when I do the presentation, goes to how I'm using it for levitation.
Oh, come on.
So I hope you guys all got that, and I hope you can see it. The coil's in green, so it's a little light. The bifilar, the secondary, comes off here. And in this circuit, I just put a capacitor here so that you understand that this is pulse. So when your primary is pulse and your secondary feeds, it fills up, this has to either be a pulse or it's got to go to a battery but it has to, if it's going to a battery, it's got to have a diode, or you can use this secondary, ground one side, leave one side open, but prepare yourself for the sparks that come after, because your whole room's going to go static. So there, I let out some golden apples there for y'all. I hope you take it and run with it. I hope it works for you. And that's the circuit. So
that's so amazing.
Nice.
This, I don't know if you can see this.
Oh, hold on.
Yep.
This is going to be the next stage. I don't know if you can capture the inside there. You see how it's layered?
Yeah, we see it.
Okay, so here's the back side. And then it's layered in such a way, it looks like a reactor. So it's wound in such a weird way. But on the inside, it forms layers. So there's a wrapping. And then if you can look, there's a double wrapping. And then there's a triple wrapping, like a Stubblefield coil. But it's all on the inside. And then the outside is uniform. There's a reason for this. I'm looking for a chemical reaction due to the static electricity created by the fields in this coil. So that's one of the next projects that we're going to work on in the future. And we'll do some live experiments with this thing, because I put these coils in water, and I'm going to say that there's anomalies that even I don't understand that require other people to see so that they can help me understand what's going on, because it's that kind of crazy. You know what I mean? So yeah.
Gerald,
Nice.
you've given us a lot to think about, and there's a lot to unpack here, but you have given us a lot of cool videos and cool demonstrations of real life devices that we can actually apply to our everyday life. So it's not like, some abstract idea. You're explaining how you can extract energy from the vacuum,
I believe I am. I mean, I can't prove that yet. It's going to take to get into your hands and you guys to do the experiments to prove it. Right now, pardon the expression, but I could be talking out of my ass. I'm not, but until you get this in your hands, how do you really know, right? So I try to explain to the best of my ability the truth that I know and have experienced, so that when you do get it in your hands, you go, wow, that crazy nut actually had it. That kind of thing, right? So, it's to do the best I can to get it into everybody else's hands and to think, right? Making people think about this is the most important thing, because what happens if the next Albert Einstein comes out of playing with this stuff? I don't know that. And that could help everyone. I don't know. So just making people think and working on this, that's joy in my heart. And joy is the thing I'm doing this for. So let's go for it, everybody.
It's great work. I love
Nice.
what you're doing, Gerald. Continue up the great work.
Hey, don't kid yourself. You guys are doing some great work too. We're all doing the same thing. It's all based on the exact same principle, just in different ways. We're coming at it from different angles. And that's freaking beautiful, because then the more angles we come at that same principle, the more people can understand it. The garage guy, the physicist, the scientist, the doctor, whoever. That's what we want to get at, right? That's my
Just use some good old common sense language that everybody knows. Quit with the highfalutin. We'll just keep it easy.
Damn straight. Hey, we could do the highfalutin just for the physicists, but we want to make sure that everybody can understand this. This isn't for the elite of the most prestigious scientific communities. Sorry, I don't mean to be a dick. I'm just...
You just don't like them at all. We know better, Gerald.
Yeah, I know.
Indubitably.
I can do voices. It's just sometimes it comes off as prejudice, and I'm not. I the least prejudiced person you can possibly imagine. I got beat up for the first 7 years of my life for being white. I know what the other side is like. Oh. So there's not a prejudiced bone in my body. So when I joke about these voices, I apologize if it offends anyone. It's for humor only. Like my dad used to do this Irish voice, so I apologize to those that are Irish if this offends.
Well, hold on. His thing says blog Irish. Hey, it's not blogish, it's blog Irish.
There you go. Well, when it comes to women, as me dear departed father used to say, you can't live with them, and marriage is illegal. He used to do that a lot because he had a bit of Irish in him, so he used to joke like that. So I apologize if I offended anyone. I just had to do that.
Not at all.
Okay.
Your Irish accent's better than mine.
Are you Irish? Is that where you come from?
Yeah, I'm from Belfast.
Oh, well, tip of the hat to you.
Northern Ireland. Yeah.
Northern Ireland.
Yeah.
I see. Yeah.
Nice.
Sorry, I knew a lot of people growing up from different backgrounds, so I kind of picked up on accents. I like to have fun with life. It's short. You never know when it's your last day, man. You know what I mean? So,
yeah.
Hey, you never take life too seriously. You'll never get out alive, right?
So true. So true. You have to have fun with it, man. You have to laugh because, you know, we said, it's, you never know when your last moment is. Be standing here one day and, the next I'm not. That's why I'm trying to get this out. And part of my dead man switch, if I do end up passing away, I hope that I can put in the right code before I do, or everybody's getting it no matter what. So no matter what happens, this text coming out, right? And there's a treasure buried somewhere of a copy of all my coils, a copy of all my notes, my book, everything in the dirt, hidden somewhere. And there's a treasure map. So, I mean, if I pass away, good luck to those that are going for it. I hope you find it and it does you good, you know?
Now we got Oak Island Gerald over here. We're going to be digging in a hole.
There you go.
Filling with
right?
water.
Hey, old school. Old school, man. There's nothing like old school. It's the best school, right? How are you going to find it? You going to follow me to where it is? I'm never going back there again. You know what I mean? So, hey, you do what you got to do, and I take precautions. So,
please do not put a lost ship over there by it so we get distracted.
Ship in a bottle, just for those that find it.
Such easy distractions going on around us.
There you go. Well, there's a couple nest eggs in there. Let's just say there's things that nobody's seen before that are sitting in that trunk in the ground. So there'll be something to look for if I do end up passing away one day and somebody looks for it.
Now, hold on. Are we going to be looking for multiple trunks here? Because you keep updating your stuff, from one presentation to the next. So we looking for multiple ones here?
No.
We're never going back.
No, there's some coils that'll never be in there because it's done. And I'm never going back there. It's sitting in the ground. I've forgotten about it. You know what I mean? Like that kind of thing.
That's what I'm saying. We're looking for multiple treasure chests now. We're going to be digging holes all over
Till somebody stumbles upon it like Gollum.
Well, my wife has instructions to give everything I have that I experiment on to certain individuals. So it'll get out there.
I'll end up digging up the one with all the broken stuff in it. And then blowing it off the table just because I use high voltage on everything.
That's okay.
And I'll say, "Well, did it work?"
You'll have the instructions to build a new one. So it might take you a little bit to get into the winding, but you'll get there. I don't know about something like this though. This thing was different. It was hard. I've had some hard winds before, but this one was.
Hey, does water go through it at all, or what does it do in the water? Just somebody asked earlier.
Does water go through it?
Like in the center of it, yeah.
Oh, I could put a tube with water through it. I put the whole coil in water and pulsed it.
So what is it doing in the water? Is it making pulses or what?
How do I explain this? You know how you hear the ringing from a coil running? I'm sure Ian knows what I'm talking about. You can hear that high-pitched ring.
Mm-hmm.
Well, when you put it in water, you're not hearing it. You're feeling it. It's like it's resonating the water in the bowl. And because that water's resonating, the water in your body's resonating. That's what it feels like. Does that make sense?
Yeah.
That's why I said there's some weird things, some crazy stuff that goes on with this. Right? And if I hit it hard enough, rather than pulsing it at like a regular frequency, say 432 or 528 or something like that, and I just hit the power with, say, one pulse, you can see the water go boom. You should like dropping a pebble in the water. So Gerald, there's some crazy stuff. Sorry?
You should put LEDs on it so it looks like an arc reactor, like a Tony Stark arc reactor.
I thought about that, but it's too deep though, right? His arc reactor was small, like it was maybe an inch. This is, I think, 2.5, 3 inches.
Still, I seen somebody try to replicate it, and they're like, it's not going to output more than it inputs, at the beginning of the video. And you really have an arc reactor here, basically.
Yeah, kind of. Yeah. I just don't have the resources that Iron Man did. I mean, we'd already be flying back and forth to the moon.
Hey, but the general principles are very easy. And that's the idea here. We're trying to relay to everybody in the general audiences. These ideas, they've been around for a while. Tesla did it. Bedini did it. Lots of inventors did it. It's not that hard to understand.
Nope.
It's just a couple of basic fundamentals.
If it was up to me, we would figure this out, and every one of us would come out all at once with the same thing. That is the best way to do it. Nobody gets the glory. Nobody gets the fame and fortune from it. I don't want it. And if we all came out with it all at once, then it's just a tech for the world.
Right. The prize for me is leaving the world a little bit better than I came into it. You know what I mean? Like, that's the prize for me.
I'm going to build me a Tron suit and just put your coil right on my back here. Use it as a discus. I'm going to light up my whole suit with it.
You build a suit. I got a special coil for each of your hands. And I got one for your chest that's huge. Okay, so let's make it happen. I'm in. I just don't have a 3D printer to get this stuff done. Okay? That's what I'd be doing.
I could do an artificial intelligence interface for you, too.
You know what, though? You don't need artificial intelligence. I think we as people are smarter than any AI out there. I just think that AI has a better organizational skill and recall system than the human brain. If we have that,
for sure. But what I mean by AI interface is just me talking to him. It's like, hey,
yeah, I get what you're saying.
Intelligence interface.
Yeah, I hear that totally. I love this stuff, man. This tech's amazing stuff, and I appreciate you guys giving me the chance to share it. So. Just wanted to say that.
Roll on Friday though, huh? That'll be
I'm working for it. I'm telling you, I got one more catering job to do this week, but I don't think that should get in the way of me finishing my work before Friday. But
so when is the next APEC?
I shouldn't say it that way. It doesn't matter. I was about to say it some other way. I'm sorry. What's that?
You said Friday's your next presentation?
Well, I'm gonna do the presentation on Nathan's channel, your channel. We'll do a live, right? And then I'll do the presentation. Yeah.
Which day you want to do it? Okay. Because we could do it on the weekend, we could do it on Mondays or whatever, whichever one.
Yeah. Yeah. Well, if I don't get the prep work done for Friday, then I'll email you and we'll arrange exactly when we're gonna do it. But I want to do it immediately, right? Like as soon as possible. But I also want to do it with a live demonstration. I don't want to be these guys that puts out a paper and you got a, you know, a nice PDF and that's all great and everything, but I'm a hands-on kind of guy, right? Give me a wrench, give me a, you know, let's get it done, right? So I imagine
I'm a visual learner myself.
Yeah, see, and I imagine there's a lot of other people out there that are like that too. I mean, this science is easy to be done. It's just
I've always been under the impression that some of these people, they're not going to believe it until they see it with their own eyes. You know what I mean?
Some people won't even believe it when they see it.
Right. But we'll turn a few.
Hopefully. There was an electrical engineer friend of mine when I started out in all this, and he seen what was happening, and he went, you know what? That's impossible. I can't explain it. Therefore, you're wrong. And I didn't talk to him again, ever. He was just mad at me. So I don't know what to say to that.
You get a lot of haters, man. You get a lot of haters.
Well, you get a lot of people that don't understand and they don't want to understand. They come up against a brick wall. And like Ian had mentioned earlier, their work, their whole life's work is based on it. You get some guy like me coming along and saying, you're wrong. Well, I don't think they're wrong. I just think they came at it from a different angle. And we came at it from the right angle. We're all headed towards
someone
the same
like that. You're never going to convince, you know.
Unfortunately, no. Like a physicist, you'll never convince a physicist because his theories. He writes papers. He's got a PhD, maybe. You know, I don't know. He's got to support his work and his friends' work. I get that. Peer review, teach your own, but I'd much rather give it to everybody. That's my peers, not somebody with a PhD stating that they're smarter than me because they have papers. You got papers. Sorry, I shouldn't do that. I apologize.
Do that.
But
if it works, you can't argue with it, right? If it works,
that's right.
And if it doesn't, hey,
you just gotta study it and figure out how it works at that point, you know.
And if it doesn't, I'm eating my own shoes. You know what I mean? Because I'm wrong. Well, then I'll be wrong and I'll admit it. You know, maybe I'll get some salt and sugar with this sucker, but until that day comes, I'm still pushing out what I can push out because that's what I'm seeing and experiencing. So yeah, I'm gonna put my shoe back on. Yeah. So that's where we're at. I mean, hey, physics, I think they were doing great for the longest time, and then it was like they were headed down the path of truth, and then they went and started following a narrative. And it's not their fault. It's more like we talked about earlier. They go where the money is. And the money is being directed in certain ways to keep them away from experimenting with this stuff and finding out what's truly going on with electricity. So that's my opinion. If I'm wrong, I'm wrong.
Oh, I agree with you for sure. Yeah.
Mm-hmm.
Hey.
So this has been an amazing stream, but I'm getting the stink eye over here.
Yeah, we're all about there, man.
Yeah.
I'm gonna end my stream in a few minutes.
Hey guys, anything you need to plug, anything going on, go ahead, one at a time, let it out.
Go ahead, Ethan. Or Ian, I'm sorry.
No, I'm good. I'm just waiting for Friday.
We're all waiting.
I'm waiting too, guys. I'm sorry. Should have been done months ago. I agree.
We don't have no empathy for that. We know you're the one holding back, so don't be doing that.
All right. I agree. You have to wait. No.
All right, Ben, what do you got?
Oh, so everybody check out Beneficence TV. That's my channel. And I just put up a 55-minute long video on time dilation effects occurring within the thunderstorm generator. It is a fascinating video. It's highly produced. It's fun. It's funny. It's interesting, entertaining, and highly educational. And I'm going to put the link in the chat. I highly suggest everybody check it out. It's a fun watch. So that's what I got.
Awesome.
Nice.
And I'm Gerald from WP Enlighten 4 Truth. 2. Not the first one, the second one. The first channel was hacked. So please come subscribe. Let's get those subscriptions up there. And I had stated prior on a live that if I hit 1,000, I'm going to put out a tutorial on one of the coils on how to wrap them and build them. So let's get it up there.
Hold on. Ben, put it in the chat real quick. Put it in chat. Let's get everybody in there so they have it. Okay.
There you go.
So put it out there before everything comes to an end. Yeah, no, we got to get to that 1,000. I'm going to do videos every day if I have to get you to 1,000.
Well, it's funny you say that because I'm going to start pumping videos out like big time. 5 a day if I can. I'm going to pump them out. So we're going to get some info out there and see what happens.
Yeah, because you know what? I can't wait because, hold on. We're waiting for this presentation for 2 months. Now we have to wait a little bit more and wind this thing up to build our own. Okay. No, I know you're going to hand them out, but like all the rest of the people on this panel, man, I want to build my own. Okay. And I want to go through the process, and I want to screw up, and I want to have all the bad things happen so I don't ever do them again and don't never question them.
Absolutely. I want that for you too. That's why I want to give you a coil so you can blow that one up, and then you have to build your own.
He knows already. He already knows I'm going to blow it up.
Fry it and find out, man. That's the saying.
That is a saying. I'm gonna put it on the hat.
I love it. To be a shirt, fry it.
I fry
or an apron, a cooking apron.
Because I deal with a lot of high voltage, so even if it's just sitting next to me with the statics going off, it blows up on me. I fry everything. I don't mean to. And that's why I just go outside now. I got my little cart. Outside. Tired of everything blowing up on me.
You're just always statically charged. You touch something and just blow it up.
But think of how much you've learned, though. You know what I mean? Like, I go by this saying. Well, there's 2 sayings I live by, but one of them's verticos veritas, which is Latin for speak the truth is a way of life, right? And the other one, well, stay true, stay you, right? So when you're doing all these experiments, just remember, be careful. Try and keep one hand in your pocket because, like Nathan says, you're going to fry it and find out.
Yeah, the one hand rule. Exactly.
Yeah. Gotta have that pocket pull rule. Never can yell at anybody about that again.
High voltage is insane, but I love it.
Oh,
yeah. This has been great, guys. I
appreciate
guys, the time.
Yeah. That's everybody.
Well, thanks for having me on as well.
Yes, definitely. Awesome, man. I appreciate your work, and I appreciate you looking at mine. That's, like I said.
Hey, it's a great thing.
I can't wait until you build your own and not get electrocuted like I did. And we want to give a big hand to Nathan for our host here. I want to say thank you for bringing us all on. And then again, one to Ben. You're doing great work. Appreciate that. Right?
Yeah,
if you ever come to Canada, I'll give you an amp. I have like 6 of them sitting in the other room. So
Thank you for everybody in the chat. You guys are awesome today. I tried to put up as many comments as I could, so did Ben. So we're working on it. Thank you guys all for showing up today and having a good time with us. Absolutely amazing show, guys. Thank you, everybody, for being here.
Yes, thank you.
Thanks, everyone. I hope you have a great night.
Thanks, Nathan.
Thanks.
You guys.
Have a good night, everybody.